Good evening, and welcome to the Sleepy Scientist, a place where curiosity drifts at its own pace and the universe slows down just enough for you to breathe. Tonight, we're setting our sights on a world that has captivated dreamers, scientists, and storytellers alike: Mars. A quiet desert hanging in the cold of space, rust-red and silent, yet endlessly alive in the human imagination. Before we begin our journey across this distant world, I'd love to know, where are you listening from tonight? Whether it's a city glowing softly under streetlights, a countryside wrapped in fog, or somewhere in between, it's always fascinating to see how far these stories travel. If you enjoy these calm explorations, a like and a gentle tap on the subscribe button help the channel reach more sleepy minds like yours. And if you're already subscribed, thank you. Don't forget to ring the notification bell so you won't miss the next quiet journey into the wonders of science. I hope this video isn't too interesting that it keeps you awake, but if it does, at least you'll drift off knowing a little more about the universe than when you started. So settle in, let the world dim around you, and let's begin with a question that has echoed for centuries. What is it about Mars that makes humanity dream? Mars has always been the planet that feels almost familiar. From Earth, it shines like a steady ember in the night sky. Not as brilliant as Venus, not as distant as Jupiter, but close enough to stir a strange sense of recognition. Long before telescopes revealed its surface, Mars had already found a home in mythology. To ancient watchers, it was the wandering star of war, its red glow a celestial pulse of conflict and courage. Yet beneath that fiery symbolism lay something quieter, the reflection of a world that once might have been alive. In many ways, Mars is a mirror held up to our hopes and fears. It is the promise of discovery and the warning of loss, a planet that teases us with traces of rivers long gone and valleys carved by forgotten floods. For centuries we've asked the same questions. Did life ever thrive there? Could it again? And what can this frozen desert teach us about our own fragile home? This story's not just one of rock and dust, it's about wonder, a slow unfolding of knowledge as each new mission, each photograph and each whisper from a distant rover reveals another piece of its quiet puzzle. It's about how a planet can shape our imagination, drawing poets, physicists and engineers alike toward a single red horizon. As we drift through the rust-tinged light of this world, we'll wander through its mountains and canyons, its storms and seasons, its moons and myths. We'll listen to the stories told by ancient astronomers and the voices of robotic explorers that hum softly across its plains. Because somewhere, amid the silence of that desert, lies the dream of humanity. A question we've been asking since we first looked up at the night sky and saw a faint red light burning back at us. Could Mars one day feel like home? In the darkness of the night sky, Mars glows with a soft, rusty light, steady and warm, like the last ember of a dying fire. It's not the brightest planet nor the largest, but it has something the others lack. A distinct, almost human familiarity. There's something about that red hue that stirs the imagination, as if the planet itself remembers things we've long forgotten. The colour that defines Mars, that deep iron-orange dust we see through telescopes, comes from a simple chemical truth. Its surface is coated in iron oxide, the same compound that forms when metal rusts here on Earth. In other words, Mars is covered in cosmic rust. Billions of years of slow chemical weathering turned once grey rocks into the reddish powder that now paints every mountain and dune. When sunlight scatters off this dust, it gives the planet its characteristic glow, a world blushing softly in the cold. That gentle red tint has fascinated observers since ancient times. To the Babylonians, Mars was Nergal, a god of destruction, The Romans saw the same red glimmer and imagined the god of war, his sword gleaming across the heavens. Even without telescopes, our ancestors could sense that Mars was different. Not serene like Jupiter, not romantic like Venus. Mars carried the colour of blood, and with it, the weight of stories. The first person to really peer at it closely through a telescope was Galileo in the year 1609. What he saw was a small round disk, not just a wandering star, but a world. Over the next few centuries, astronomers would watch that tiny red circle swell and shrink as Mars moved through its orbit, its seasons shifting subtly. By the late 1800s, better telescopes revealed darker patches and lighter deserts across its face. Some observers, like Percival Lowell, imagined they saw canals, vast, intelligent-made waterways crossing the Martian surface. Those lines turned out to be optical illusions, but the belief that Mars might host life had already taken root. Even when science stripped away those dreams, the wonder didn't fade, because the truth of Mars turned out to be just as poetic. Beneath that rusty blanket lies a world of frozen volcanoes, dust plains, and canyons so wide they could swallow continents. The red colour, far from being lifeless, is the evidence of deep transformation, a sign that Mars once had air thick enough for water to flow and minerals to oxidize. It's not the colour of death, but of memory. If you were standing on the surface of Mars at sunset, you'd see something rather surprising. The sky above wouldn't be red. It would be a soft butterscotch orange, fading into pink, and the setting sun itself would glow blue. On Earth, blue light scatters in all directions, giving us blue skies and red sunsets. But on Mars, the dust is so fine and abundant that it scatters the blue wavelengths forward instead, making the sun's light blush in reverse. A blue sunset on a red planet. It's hard not to smile at the quiet irony of it. That same dust is what gives Mars its otherworldly softness when seen from afar. Through the thin atmosphere, sunlight diffuses gently, creating a hazy horizon where day and night melt together. There are no trees, no waves, no signs of motion, only stillness. It's as if the entire planet is paused between breaths, and yet, beneath that calm, there's constant change. Winds sweeping over dunes, frost gathering on boulders, dust devils spiraling lazily across plains that have seen billions of years go by. From space, Mars looks like a painting made with shades of copper, ochre, and rust. Each tone tells a story of mineral and time. Basalt from ancient lava flows, hematite formed in water, silicates polished by storms. It's a colour palette born of chemistry and solitude. When the first orbiters began sending back images in the 1970s, people were startled by how familiar the Martian deserts looked. Craters resembled the scars of our moon, but the dunes, rocks, and horizons felt like something from our own planet, like the high deserts of Chile or the red mesas of Arizona. That resemblance fuels a quiet sense of connection. Mars is not a jewel-like gas giant or an ice-cloaked mystery. It's solid ground. You can imagine walking there, feeling the crunch of dust beneath your boots, the low pull of gravity making each step almost effortless. You can imagine brushing red powder from your glove and watching it drift slowly, lazily, to the ground. That imagined touch is part of what makes Mars so irresistible. It's not only beautiful, it's tangible. The planet's colour even tells us about its past. For iron to oxidize, it needs oxygen, but Mars doesn't have much of it now. That means its reddish hue formed long ago, when the planet's environment was wetter and more reactive. The oxidized minerals we see today are relics from that era, preserved under a thin sky and relentless cold. In a sense, Mars is a fossil planet, its rusted skin a record of chemical time. Viewed through a telescope, Mars still holds that hypnotic appeal. Even a modest backyard instrument reveals its pale polar caps and faint surface markings. During close approaches to Earth, every 26 months or so, the planet brightens dramatically, as if leaning closer to say hello. Amateur astronomers around the world set their alarms for the middle of the night just to catch that fleeting moment when Mars looks almost touchable. Then slowly it drifts away again, shrinking to a tiny orange dot. It's a reminder of distance and patience. Two things Mars seems to teach better than any other planet. Distance, because it lies tens of millions of kilometers away. Patience, because it reveals its secrets only to those who keep watching. Its redness isn't a warning, but an invitation to look closer, to find life in the color of stillness. In the end, that soft rust-red glow that has traveled across space for millennia reaches your eyes as a whisper from a desert world. A quiet ember hanging against the night. It's both strange and familiar, barren, yet full of meaning. And as you watch it shining there, steady and small, it's easy to understand why humanity has spent centuries wondering not just what Mars is made of, but what it might mean. Mars may look like a frozen desert today, but its surface tells a story written in water. Not the trickling kind that carves valleys on Earth now, but ancient floods and vanished seas that once shaped the face of a living planet. From orbit you can trace winding riverbeds that twist across plains and disappear into craters, as though the planet itself once had veins that ran with water and then quietly dried. One of the first clues came in the 1970s, when NASA's Viking orbiters sent back detailed photographs. The images startled scientists. Across Mars were networks of channels, hundreds of kilometers long, snaking through the dust. They looked so much like dried river valleys on Earth that geologists could almost imagine standing on the banks and hearing the faint echo of rushing water. The planet's ancient terrain resembled the bones of a world that once flowed, then froze in time. Those river-like channels are found everywhere, winding valleys in the highlands, braided deltas in craters, and fan-shaped deposits that look remarkably similar to those left behind by ancient floods on Earth. Some even show evidence of erosion and sediment layering, unmistakable signatures of liquid carving its way through rock over countless years. Yet when Viking tried to find any trace of moisture, the surface was bone dry. It was as if Mars had gone from a blue world to a barren one in the blink of geological time. To understand this transformation, scientists began looking at the smallest details, the minerals scattered across the planet's surface. Certain minerals can only form in the presence of water. On Earth, clays, sulfates, and hydrated salts all tell stories of wet conditions long past. When spacecraft like Mars Express and later Curiosity began analyzing the planet's soil and rocks, they found exactly those minerals. Some had formed in neutral mild water, others in acidic evaporating pools. Each discovery was another piece of the puzzle, showing not just that water had been there, but that it had lingered for millions of years. Imagine Mars 3 or 4 billion years ago. The sun was younger and slightly dimmer, but the planet's atmosphere was thicker, perhaps thick enough to trap heat and allow rain to fall. Vast plains would have shimmered with shallow seas. Rivers might have wound through volcanic landscapes, gathering into basins that became lakes. There may have been waves lapping at crater shores, clouds drifting across the sky, and rain darkening the red dust into ochre mud. It was a gentler time in a world now defined by silence. One of the most haunting places on Mars is the Jezero crater, the landing site of NASA's Perseverance rover. From orbit, it's easy to see why scientists chose it. The crater's rim holds the remains of a river delta, frozen in stone. You can trace where the ancient river entered the basin, spreading its sediment like a fan before meeting what was once a lake. It's a perfect geological time capsule. Each layer of sediment could contain chemical signatures, perhaps even microfossils, from a time when Mars was wet enough for life to dream of existing. Elsewhere, the planet's surface is marked by channels that suggest sudden, catastrophic floods. These are not gentle streams, but torrents that must have gushed with terrifying power. They may have been caused by underground ice melting from volcanic heat or meteor impacts, releasing short-lived oceans that carved canyons before vanishing into thin air. The Martian landscape still bears those scars: deep valleys, chaotic terrains, and collapsed surfaces that tell of violent hydraulic events. Even in stillness, Mars remembers motion. In the mid-1990s, the Mars Global Surveyor gave humanity its clearest view yet of these lost waterways. It revealed not only valleys and channels, but also the basins that could have been ancient seas. One such region, called the Northern Lowlands, is so smooth and flat that many scientists suspect it once held a vast ocean, an entire hemisphere of water. If that's true, then Mars was once half blue, half red, a planet of coasts, storms, and tides. The thought is both beautiful and a little tragic, an ocean world that dried before it could flourish. The chemistry of the surface supports that idea. In several locations, orbiters have detected chlorides, essentially salt deposits left behind as water evaporated. On Earth, you'd find similar features at the edges of dried-up lakes and desert playas. Some Martian salts appear in polygonal patterns, hinting that they may have once been seasonal ponds or shallow basins that froze and thawed. Even in their emptiness, they speak of rhythm, of a time when Mars had seasons not unlike our own, with ice melting into spring floods and refreezing as winter returned. Today, the only water left on Mars hides as ice. Some of it lies beneath the poles, but much of it is buried underground in frozen reservoirs. Orbiters using radar instruments have mapped these icy layers, finding kilometre-thick deposits beneath dunes and plains. In 2018, one radar signal even hinted at a patch of liquid brine beneath the South Polar ice cap, possibly a salt-rich pond that remains unfrozen. Whether that signal truly represents liquid water is still debated, but the possibility alone reminds us how much of Mars remains unseen. If you could stand on Mars and follow one of its ancient riverbeds, you'd find landscapes both familiar and alien. Pebbles rounded smooth by ancient currents, layered cliffs where silt settled in slow motion, and everywhere dust, the final blanket over what once moved. The scale of it all is hard to grasp. Some channels are wider than the Amazon and stretch for thousands of kilometers, yet now they are as silent as the moon. Scientists continue to reconstruct this vanished hydrology like detectives piecing together a lost civilization. Each rover adds a new clue. Opportunity once found tiny mineral spheres called blueberries, formed by groundwater seeping through rock. Curiosity drilled into mudstone that had formed at the bottom of a long-gone lake. Perseverance is now collecting samples that may someday return to Earth, carrying whispers from those forgotten waters. The question that lingers over all this is simple and profound. Where did the water go? Some escaped into space when the planet's magnetic field faded, leaving its atmosphere vulnerable to the solar wind. Some froze into the soil, trapped forever in permafrost, and some may still flow faintly today, not as rivers, but as trickles of salty brine that seep down crater walls before evaporating in the thin air. These are fleeting, ghostly flows, the planet's last sighs of moisture. Yet even without rivers, Mars still carries the feel of a water world. You can see it in the patterns left behind, the way valley networks converge like dendrites, the symmetry of deltas, the shapes that only erosion by liquid can sculpt. They are geological memories, recorded in rust and sand. It's strange to think that the same element that gives Mars its colour, iron reacting with oxygen, once relied on that very water to form. The red dust we see today is a remnant of that vanished age. There's a certain melancholy in that thought. On Earth, rivers are symbols of life and renewal, forever moving toward the sea. On Mars, they are symbols of what once was, frozen in time, unmoving, yet enduring. They are the shadows of motion, carved by something that has long since left. But perhaps that's part of what draws us to the planet. It feels unfinished, waiting, as if those riverbeds are invitations, not graves. When you look at Mars through that lens, its dryness becomes a kind of poetry. The rivers are gone, but their stories remain written across the landscape for anyone patient enough to read them. Each channel, each delta, each mineral tells us that Mars wasn't always this quiet. It once had clouds, weather and flow, the sound of water moving over stone in an alien world. Now, as we study those empty valleys and collect samples of dust that hasn't felt rain for billions of years, we're not just learning about Mars, we're learning about the fragility of worlds, about how thin the balance between warmth and cold, between air and emptiness can be. And maybe, in a quiet way, we're learning about ourselves too, about how easily the dream of life can slip away if the rivers stop running. Mars may have lost its water, but it hasn't lost its memory of it. Every dry channel is a whisper from a past world, a promise that even in the silence of space, the traces of movement remain. And in that whisper, humanity keeps listening, wondering whether someday the rivers might return, and whether we might be there to see them flow again. If you're enjoying this calm journey across Mars, you'll love the rest of our Sleepy Planet series, a relaxing collection of videos exploring each world in our solar system. New episodes will be released every week and added straight to the playlist, so you can drift from one planet to the next whenever you like. If Mars is a world of silence today, it wasn't always so. Long ago its surface shook with fire. The planet that now lies cold and still was once a forge of titanic heat, its crust bursting open again and again to build mountains taller than anything the solar system has seen since. Among them, one rises so high that it almost scrapes the edge of what a planet's gravity can hold together. Olympus Mons, the giant of giants. Olympus Mons isn't just large, it redefines the idea of a mountain. From base to summit, it climbs nearly 25 kilometers, about 3 times taller than Mount Everest. Its base alone would stretch across France. If you stood on one edge of its caldera, the other side would vanish beyond the horizon. The slope, though, is surprisingly gentle. You could walk up it without ropes or oxygen, though it would take you weeks and an absurd amount of snacks. From afar, it doesn't look sharp or jagged like Earth's volcanic peaks, but rather like a colossal shield, a vast dome of ancient lava flows that spread outward for hundreds of kilometers. To understand how such a giant formed, we have to imagine Mars when it was young, a world alive with magma, where the crust flexed and cracked under enormous pressure. On Earth, volcanic hotspots like Hawaii or Iceland erupt through moving tectonic plates. As the plates drift, new volcanoes form while old ones are carried away. That's why our mountains are tall but modest compared to Mars's titans. Mars, however, has no plate tectonics. Its crust is fixed, a single shell. So when a hotspot formed beneath it, the same vent kept erupting in the same place for hundreds of millions of years. Lava piled up, again and again, until it built Olympus Mons, a monument to patience and persistence sculpted by fire instead of wind. Around Olympus, Mons lies the Tharsis region, a volcanic plateau roughly the size of the entire continent of North America. Here, 3 other immense volcanoes stand in a near-perfect line: Asia Mons, Pavonis Mons, and Ascreus Mons. They rise like sentinels over the red plains, each one a shield volcano built from countless layers of basalt. It's almost as if Mars decided that if it were going to make mountains, it would do so properly and never again. These mountains are so huge that they may have changed the entire planet's shape. The Tharsis bulge added so much mass to one side of Mars that it tilted the planet's crust, possibly triggering global fractures, including the enormous canyon system known as Valles Marineris. In that sense, the volcanoes are not just features on Mars, they are its architects. Their eruptions carved its valleys, thickened its atmosphere, and perhaps even made the planet temporarily warmer, given its rivers one last chance to flow. When we look at them now, frozen and dark, it's hard to imagine the violence they once unleashed. Picture lava fountains taller than skyscrapers, glowing rivers that flowed for hundreds of kilometers, and an atmosphere thick with ash and lightning. Olympus Mons was active for an extraordinarily long time, possibly from 3.5 billion years ago until as recently as 100 million years ago. On geological timescales, that's practically yesterday. It's not impossible that some parts of Mars still hide warmth beneath their crust, waiting for a chance to breathe again. The summit of Olympus Mons is crowned by a massive caldera, a depression nearly 80 kilometers wide, formed when the lava chamber beneath it emptied and the ground above collapsed. Inside it are smaller pits and terraces, like the nested craters of an ancient cathedral roof. Imagine standing there, the horizon curving away beneath a salmon sky, the air so thin you'd need a pressure suit to survive, and the ground beneath your feet made entirely of old, frozen lava. The sheer stillness of it would feel almost sacred. You'd be standing atop a volcano the size of an entire country, and yet it would be utterly silent. That silence is perhaps the most haunting thing about these mountains. On Earth, volcanoes roar, rumble and smoke. They're alive in ways you can hear and smell. On Mars, the air is too thin for such drama. If Olympus Mons erupted today, its thunder would vanish before travelling a kilometre. The lava would glow in eerie silence under a pale pink sky. There would be no crackling, no booming, just the soft hiss of gases escaping into the void. Mars muffles its own fury. As spacecraft have mapped the planet in greater detail, scientists have found dozens of smaller volcanoes scattered across its surface, each with a story to tell. Some, like Elysium Mons in the Eastern Hemisphere, show signs of relatively recent lava flows. Others are ancient and eroded, their once smooth slopes pitted by impacts and dust. The variety of volcanic features, cones, domes, ridges, suggests that Mars experimented with all kinds of eruptions over its lifetime. For a world now thought of as cold and dead, its past was full of heat and movement. The chemistry of Martian rocks confirms it. Many are basalts formed by cooling lava, rich in iron and magnesium. Some even show evidence of interaction with water, lava meeting ice, creating explosive steam and strange glassy minerals. There may once have been hydrothermal vents where volcanic heat met underground water, forming warm, mineral-rich environments that could have nurtured microbial life. On Earth, such vents teem with life even in complete darkness. On Mars, we can only wonder what might have stirred in those hot springs before they froze forever. Volcanoes also help shape the Martian sky. Each eruption released vast amounts of gas, carbon dioxide, water vapor, sulfur dioxide. For brief periods, this could have thickened the atmosphere and warmed the planet through greenhouse effects. Some scientists think that repeated volcanic episodes may have extended the planet's habitable window, allowing liquid water to persist long after the magnetic field had faded. If that's true, then the mountains of fire didn't just sculpt the landscape. They prolonged the planet's chance at life. Even now, orbiters continue to scan Olympus Mons and its siblings for signs of modern activity. Small landslides, fresh lava-like textures, and subtle thermal anomalies hint that Mars may not be entirely done with its volcanism. It's quiet, yes, but not necessarily extinct. Perhaps deep beneath the crust, magma still stirs slowly, patient and unseen. If that's true, then Mars is only sleeping. It's strange to think that a world so calm today could once have burned so fiercely. Yet that duality is what makes Mars fascinating. The same planet that hosts dry riverbeds and dusty plains also built mountains that reach the edge of space. It's a place where stillness and violence have taken turns for billions of years, leaving behind a surface that tells both stories at once. Standing on the flank of Olympus Mons, you wouldn't feel small. You'd feel suspended between scales. Above you, the sky fades to black within minutes of climbing. Below, the horizon curves away in gentle red arcs. There would be no sound, no wind strong enough to stir your suit, no sense of danger, only the vast weight of history pressing quietly from beneath your feet. A volcano that once roared with flame now rests beneath dust, its last exhalation lost to space. The mountains of Mars remind us that even the fiercest worlds grow quiet. Fire becomes stone, motion becomes memory. And though the volcanoes are now extinct, their presence still shapes the dreams of those who study them, a testament to the power of time to turn fury into peace. In the glow of a telescope, Olympus Mons is just a faint bulge on a reddish disk, but in truth, it is an entire saga of planetary creation written in frozen lava. It tells of a time when Mars was alive, restless, and full of heat. And as we look up from our own small world, we can't help but wonder whether somewhere beneath that silent surface, the embers still remain, waiting, not to destroy, but to remind us that even in the coldest corners of the cosmos there was once fire. Stretching across the Martian equator like a wound that never quite healed lies one of the most extraordinary features in the solar system, Valles Marineris. It is a canyon so vast that Earth's Grand Canyon would fit inside it dozens of times over. From end to end, it stretches for nearly 4,000 kilometers, about the same distance as the entire continental width of the United States. In some places, it plunges 7 kilometers deep, enough to swallow Mount Everest and still leave room for a few clouds. It is less a valley and more a planetary fracture, a scar that divides the face of Mars. Seen from orbit, Valles Marineris looks like a great claw mark across the red surface, a reminder of the planet's restless past. The name itself means Mariner Valleys, after the Mariner 9 spacecraft that first revealed it in 1971. When those first photographs arrived, scientists were stunned. Nothing like it existed anywhere else in the solar system. The question was immediate. What could have torn a world open like this? For a long time, people assumed it must be a colossal river valley. After all, Mars is full of channels carved by ancient water. But the more closely scientists studied it, the clearer it became that this was not the work of erosion. There were no river deltas, no layered sediments like those seen in dried lakes. Instead, the cliffs looked like fractured crust, the kind you'd expect when a planet's skin is stretched too far and begins to tear. The prevailing theory today is that Valles Marineris began as a massive rift, the Martian equivalent of Earth's East African Rift Valley, but on an incomprehensible scale. When the Tharsis volcanic region swelled with molten rock billions of years ago, it put enormous stress on the surrounding crust. The land cracked under the pressure, and vast blocks of rock began to pull apart, leaving deep chasms between them. Over time, landslides, wind erosion, and perhaps even short-lived floods widen those fissures into the Grand Canyon complex we see today. If you could stand on the rim of Valles Marineris, the view would be dizzying. The cliffs drop away so sharply that the bottom is lost in haze. Layers of rock in subtle reds, browns, and golds trace the history of Martian geology, like the pages of a book. In the distance, other cliffs rise again, so far away that the thin air turns them a soft blue. The horizon seems to have split in two, and between them lies an abyss wide enough to swallow a continent. Inside the canyon, the terrain is far from uniform. It isn't a single trench, but a labyrinth of interconnected valleys, each with its own shapes and secrets. Some sections, like Kanda Chasma and Melas Chasma, are broad and flat-floored, while others, such as Eos and Tithonium, are narrow and steep. Landslides the size of cities have tumbled from the walls, leaving fans of debris that stretch for kilometers. Some of these landslides are so fresh-looking that geologists suspect they may have occurred relatively recently, perhaps triggered by Mars quakes or by the slow creep of gravity over eons. One of the most striking discoveries came when orbiters mapped the region in detail and found signs that water, at least for a time, might have played a supporting role. Certain areas show layered sediments and minerals that typically form in the presence of water. It's possible that after the canyon formed, groundwater seeped through the fractured crust, pooling temporarily in the basin floors. Imagine a place where waterfalls once cascaded down cliffs taller than the Himalayas, feeding short-lived lakes that froze or evaporated in the thin air. The traces of that possibility remain etched into the rocks, a faint memory of movement in a landscape now utterly still. The lighting inside Valles Marineris would be surreal. The sun, already dimmer on Mars than on Earth, would strike the cliffs at low angles, scattering reddish light through the dust-filled air. The canyon's depths might appear darker, cooler, almost violet in tone, while the upper rims would gleam with copper and gold. If you shouted across the gap, your voice would vanish almost instantly. The air too thin to carry sound far. Silence would dominate, broken only by the whisper of wind moving dust along the rock. That quiet might be deceiving, though. The canyon still shifts, even now. Thermal stress cracks the rocks as the temperature swings hundreds of degrees between day and night. Dust slides down the slopes in slow, graceful avalanches. Occasionally sensors aboard orbiters detect faint quakes beneath the surface, tremors that remind us Mars isn't quite finished moving. The planet still breathes, just very slowly. In geological terms, Valles Marineris is a record of planetary failure, a place where the crust simply couldn't hold together. But in another sense, it's a masterpiece of natural architecture. The forces that tore it open also exposed layers of rock that might hold clues to the entire planet's history. Every cliff face is a cross-section of time. Basalt flows from volcanic ages, sedimentary layers from wetter periods, and impact deposits from cosmic collisions. It's as if the planet opened itself up just enough to show what lies beneath its skin. Some researchers suspect that the canyon may even hide traces of ancient microbial life. The walls could shelter minerals that once interacted with water, preserving tiny organic compounds from the planet's early days. Future missions might one day descend into those shadowed depths to search for fossils too small to see, yet vast in their significance. The irony is that one of Mars's most violent features could also be its most promising cradle of evidence for life. From a distance, Valles Marineris dominates the planet's landscape. If you could somehow stand on Phobos, the larger of Mars's two moons, the canyon would be visible as a dark gash stretching across the equator. It's hard not to feel a sense of awe, and perhaps a little melancholy at the scale of it. On Earth, we measure canyons in kilometers. On Mars, they stretch for thousands. It's a reminder that other worlds play by different rules. The age of the canyon remains a mystery. Some parts appear ancient, their edges softened by billions of years of erosion. Others look younger, with crisp features that may have formed after much of Mars had already cooled. This suggests that the process of splitting and collapsing might have continued for a very long time, each generation of cracks feeding the next. Over that immense timescale, dust settled, cliffs slumped, and the once fiery planet fell silent. Today, robotic explorers like orbiters and rovers peer into the canyon's depths from afar. High-resolution cameras can pick out boulders only a few meters across, tracing landslides and gullies in astonishing detail. Scientists study the layers to understand how the Martian crust evolved, comparing them to similar formations on Earth. What they're learning is that Mars, though alien, follows many of the same rules of physics and geology, only magnified and slowed by its smaller size and thinner atmosphere. It's tempting to picture what it might be like to stand on the floor of Valles Marineris, surrounded by walls higher than any on Earth. The air pressure there would be slightly higher than elsewhere on Mars, dense enough that human explorers might one day find it a natural shelter. Dust would drift lazily from above, piling into soft dunes. The cliffs would glow faintly under the dim sunlight, their shadows stretching for kilometers. In that silence, you could almost imagine hearing echoes from the planet's fiery youth, a low, distant groan as the crust once tore apart. But perhaps the most poetic thing about Valles Marineris is how it embodies contrast. It's a symbol of destruction, yes, but also of endurance. A scar that doesn't fade, but instead tells a story of strength through fracture. It's beautiful in the way only colossal stillness can be, a monument to the slow, unstoppable processes that shape worlds. When we look at it from orbit, the canyon doesn't appear angry or violent. It looks calm, almost serene, its edges softened by billions of years of dust. It reminds us that time heals even planetary wounds, or at least it teaches them to rest quietly. The cliffs no longer crumble with fury. They simply wait, casting their shadows across the plains like the wrinkles of an ancient face. And perhaps that's what makes Valles Marineris so moving. It is both vast and intimate, both terrifying and peaceful. It's the place where Mars reveals its vulnerability, not a god of war, but a tired world that once burned, stretched, and broke, only to settle into silence. A canyon that split a planet, and in doing so told the story of how even the strongest worlds can come undone, and still, somehow, remain beautiful. The Martian sky may look calm and inviting in photographs, but it's not the kind of air you'd want to breathe, or could. If you were standing on Mars right now without a suit, the first thing you'd notice is not the colour of the sky, but the absence of comfort. The air around you would be so thin it would feel almost non-existent, like trying to inhale at the top of Mount Everest and then dividing that by 100. The pressure is less than 1% of Earth's atmosphere, a whisper compared to our dense, oxygen-rich blanket. This ghost of a sky is made mostly of carbon dioxide, with just traces of nitrogen, argon, and a sprinkling of oxygen and water vapour. To your lungs, it would be utterly useless. Within seconds, the water on your tongue would start to boil away, not because it's hot, but because the pressure is too low to keep it liquid. You wouldn't have time to gasp. Your blood wouldn't exactly boil, as science fiction likes to dramatize, but it would lose oxygen rapidly. Consciousness would fade within moments, leaving you standing under one of the most beautiful skies in the solar system, utterly unaware of it. And yet, despite its fragility, this thin veil of air is what shapes Mars into the world we see today. It paints the sky in soft hues, sculpts the dunes, and carries dust storms across continents. It's weak by earthly standards, but it has just enough power to move sand, to erode, and to whisper across the plains. The sound of the Martian wind, recorded by the Perseverance rover, is eerie and delicate, more like a low hum than a gust. It reminds you of wind passing through an old bottle. It's the breath of a world that speaks in sighs. The Martian atmosphere didn't start this way. Billions of years ago, it may have been much thicker, enough to support lakes, rivers, even rain. Back then, volcanic eruptions released carbon dioxide, water vapor, and other gases into the air. But as the planet cooled and its magnetic field faded, the sun began to strip that atmosphere away. Without a magnetic shield, charged particles from the solar wind slammed into the upper layers, kicking molecules out into space. Over millions of years, the once dense air thinned until only this fragile remnant remained. You can see the effects of that loss everywhere. Craters and rocks remain unweathered, because there's no strong wind or rain to smooth them down. Tiny meteorites that would burn up in Earth's atmosphere strike the surface intact on Mars. Cosmic radiation constantly bombards the ground, sterilizing the top layer of soil. It's a world exposed, like a wound left uncovered. Despite all this, Mars still has weather. It has clouds, thin, high ones made of water ice or carbon dioxide crystals. And it has seasons caused by the planet's tilted axis. During spring and summer, the polar caps shrink as frozen carbon dioxide sublimates into gas, slightly thickening the atmosphere. In winter, the process reverses, and part of the air literally falls as frost, coating the ground in a delicate white layer. Imagine living on a planet where the air itself snows each year, and every breath of atmosphere is part of a seasonal tide. Even though it's faint, this air changes colour in ways that surprise the eye. During the day, the Martian sky is a dusty butterscotch orange, tinted by fine particles suspended in the thin air, but at sunset it does something unexpected. The horizon glows blue. That's because the dust scatters sunlight differently from Earth's air, sending the blue wavelength straight ahead instead of sideways. The result is a gentle inversion of what we're used to, a world with red days and blue evenings. It's almost poetic, as if Mars decided to give us the opposite of home, just to keep us curious. Temperature on Mars is a game of extremes. Without a thick atmosphere to trap heat, warmth from the sun escapes almost instantly once night falls. Daytime highs near the equator might reach a comfortable 20 degrees Celsius, but by night it can plummet to -80. The air simply can't hold on to heat the way ours does. There are no warm breezes, no dense clouds to wrap the planet in insulation, just thin, cold emptiness. The closest thing to weather you'd feel is a soft, dusty wind brushing against your suit, a faint reminder that the planet is still alive in motion. For future explorers, this frail atmosphere will be both a challenge and an opportunity. On the one hand, it offers almost no protection from radiation, meaning habitats would need to be buried underground or shielded with thick walls. On the other, it contains ingredients we can work with. The carbon dioxide could be split into oxygen and carbon monoxide using electricity, a technology that's already been tested by the Perseverance rover through an instrument called MOXIE. For the first time in 2021, Mars gave us a few grams of oxygen, a breath's worth, created from its own air. It's a small step toward the possibility of living off the land on another world. The air is also just thick enough to allow for flight. Barely. The Ingenuity helicopter, a small drone that hitched a ride with Perseverance, proved it. Flying on Mars is like trying to hover on Earth at an altitude of 30 kilometers, higher than any helicopter can normally go. To lift off, Ingenuity's blades had to spin over 2,000 times per minute, slicing through air as thin as fog. Yet, it worked. Beautifully. Each flight was a tiny miracle of physics, showing that even in an atmosphere 1% as dense as ours, motion is still possible. It's humbling to realize that what we call sky on Mars is almost nothing. A few molecules of carbon dioxide, a trace of nitrogen, and a delicate haze of dust. Yet it defines everything we see from orbit. The thinness of the air is what lets sunlight scatter so cleanly, what gives the planet its soft glow and its transparent horizons. It's what allows dust storms to stretch around the globe, painting the atmosphere in golden tones. Without this frail veil, Mars would be a sharper, harsher place. Too dark, too cold, too silent. The soundscape, if you could call it that, would feel otherworldly. Because sound needs air to travel, everything is muted. A rock striking the ground would make a dull, delayed thud. The hum of machinery would be muffled as though wrapped in thick cloth. Even your own voice would sound strange. Lower, slower, and barely audible beyond your helmet. You could shout as loud as you liked, and someone standing just a few meters away might barely hear you. Mars is a place where sound itself struggles to survive. That ghostly quiet is part of its charm. It reminds us that this is a world shaped by absence of air, of warmth, of noise. Yet within that emptiness lies beauty. The sky, though thin, still glows at dawn and dusk. High above, wisps of cloud drift in slow motion, moving so gently they might take hours to cross the horizon. And every so often dust devils rise and dance. Tall, swirling columns of fine red powder twisting across the plains like spirits of the wind. Scientists studying the Martian atmosphere see it not as dead, but as dynamic. It still changes daily and seasonally. There are breezes, gusts, and whirlwinds. There are thin mists that form before sunrise and fade in the morning light. There are invisible tides of carbon dioxide that shift between poles and equator. In its own quiet way, Mars still breathes, and perhaps that's the most moving thing about it. The air may be too thin to hold warmth or sustain life as we know it, but it's still an atmosphere, the planet's final whisper, holding on against the void. Each molecule has survived the constant battering of solar winds for billions of years, defying extinction. It's a reminder that even in the most fragile environments, persistence endures. If you ever stood there, watching the pale sun climb through that dusty orange sky, you might forget for a moment how hostile it really is. The light would be soft, the colours gentle, the horizon would stretch endlessly, framed by a calmness no earthly sky could match. And in that stillness you'd realize that even a thin, fragile sky can be beautiful. A breathless reminder that the universe doesn't need to be kind to be magnificent. At the top and bottom of Mars, where sunlight only grazes the horizon, and the air grows thin beyond measure, lie its most dazzling secrets, the polar ice caps. They gleam like cosmic mirrors, shining white against a red world, and they change shape with every passing Martian season. These frozen poles are not just pretty patches of frost, they are archives of a planet's memory, preserving layer upon layer of its climate history, like pages pressed between sheets of ancient glass. From orbit, the poles look deceptively familiar. The northern one in particular resembles Earth's Arctic, smooth, swirling, and bright. But unlike our world's polar caps, which are made almost entirely of water ice, the ones on Mars are layered with something far more peculiar: carbon dioxide frost. In the coldest months, the air itself freezes solid. Carbon dioxide, which makes up most of the planet's thin atmosphere, condenses onto the surface and blankets the poles in dry ice. When spring arrives, this frozen air sublimates, turning directly from solid to gas, and drifts back into the atmosphere. It's as though Mars exhales every year, cycling its very breath between land and sky. Each Martian year, which lasts roughly 687 Earth days, brings this rhythm of freezing and thawing. In winter, up to a third of the entire atmosphere can freeze out onto the poles. Pressure across the planet drops, and winds rush toward the colder hemispheres. Then, as sunlight returns, the carbon dioxide evaporates, raising the atmospheric pressure again and sending new breezes in the opposite direction. These winds, while gentle by Earth standards, can carry enough fine dust to tint the caps with streaks of pink and tan, The result is a shifting mosaic of colour, the planet painting its poles anew with every season. Beneath this layer of carbon dioxide frost lies something more enduring, thick slabs of water ice mixed with dust and rock. The northern cap's permanent ice layer is massive. If it melted, it could cover the entire planet in an ocean 11 meters deep. Its spiral troughs and ridges, shaped by wind and sunlight, give it a hypnotic look from orbit, like a frozen fingerprint. The southern cap is smaller but more complex, made of alternating layers of carbon dioxide and water ice that record the planet's shifting tilt over millions of years. When the tilt changes, so do the poles. Warmer periods cause the ice to recede, while cooler epochs let it build again. Each layer is a frozen diary entry in the long story of Martian climate. If you could stand at one of the poles, the experience would feel alien and familiar at once. The sun would skim low over the horizon, never rising high in the sky. The light would be diffuse, filtered through dusty air, and the temperature would hover around -100 degrees Celsius. The ground would crunch beneath your boots with the brittle texture of dry ice, not snow. Every step would release faint puffs of carbon dioxide gas, like the planet sighing beneath your feet. In the distance, pale ridges would glint under a salmon sky, and the air would shimmer faintly with frost. It would be silent, so silent that you could hear your own heart beating through your suit. One of the most enchanting sights occurs in spring, when the sun begins to return after months of darkness. The warming rays penetrate the translucent carbon dioxide frost, causing gas to build up beneath the surface. Eventually, that trapped gas bursts through in jets, spraying dark dust high into the air before settling back down into beautiful, fan-shaped patterns. These spiders and fans, as scientists affectionately call them, decorate the southern polar plains like ink blots on paper. Each one marks a moment when the frozen ground came alive for a brief, breathless instant, a natural Martian fireworks display, made of dust and gas instead of flame. For scientists, the poles are among the most valuable regions on Mars. They're more than scenic, they're scientific time capsules. The alternating bands of ice and dust record changes in the planet's climate over tens of millions of years, similar to how ice cores on Earth reveal ancient air bubbles and temperature cycles. By studying these layers, researchers can reconstruct how Mars' atmosphere evolved, when it was thicker, when it thinned, and how shifts in the planet's tilt and orbit changed its seasons. Mars, after all, wobbles more dramatically on its axis than Earth does. Those tilts can swing by tens of degrees, transforming the climate from relatively mild to utterly brutal. The polar layers hold the evidence of those planetary mood swings, frozen in alternating tones of bright and dark ice. Hidden beneath the ice may lie something even more intriguing. Radar instruments aboard orbiters have detected reflections that could indicate pools of liquid water trapped beneath the south polar cap, kept from freezing by pressure and salts. If those signals truly represent liquid, they could be the most promising habitats for life on Mars today. Protected from radiation and sealed under kilometers of ice, such underground reservoirs might resemble the subglacial lakes beneath Antarctica. They could, in theory, host microbial ecosystems, tiny, resilient forms of life clinging to existence in the planet's coldest shadows. However, confirming that will take time. The signals are faint, and Mars has a habit of teasing us with mystery. Some scientists think the reflections might come from salty, slushy ice, rather than true liquid water. Still, even that would be remarkable. Salt water could remain stable at temperatures far below freezing, offering a glimpse of chemistry still in motion on a supposedly dormant world. The polar regions also play a major role in Mars' atmosphere today. When carbon dioxide sublimates in spring, It drives global dust circulation and weather patterns. Massive dust storms often begin near the poles before spreading across the planet. The same process that shapes those beautiful frost fans can help trigger winds strong enough to lift particles skyward. These storms can blanket the entire globe, dimming sunlight for weeks and painting the thin air in amber light. It's a reminder that even a cold, quiet world can still breathe with power. From space the poles appear tranquil, delicate swirls of white against ochre plains, but up close they're dynamic, even mischievous. The boundary between frost and dust shifts constantly, creeping south or north with each sunrise. Over time, the retreating edges carve terraces and cliffs in the ice, exposing the layered record below. Rovers have never visited the poles directly. The temperatures and terrain make them too hostile. But orbiters have mapped every ridge and spiral, watching how they change with the passing years. The view is hypnotic, winter advancing and retreating, like a slow heartbeat of frozen breath. Perhaps the most poetic aspect of these ice caps is how they blur the line between air and land. On Mars, the atmosphere doesn't simply touch the ground, it becomes it. Every winter, the sky falls, literally, as carbon dioxide snow drifts down, turning the air itself into part of the surface. And then, when the sun returns, the ground rises back into the sky. It's an endless exchange, a frozen dance that no other planet performs quite so gracefully. To imagine Mars without its polar caps is to imagine it without its soul. They are the planet's most visible signs of life's prerequisites: water, carbon dioxide, and change. They remind us that even in a world where liquid water no longer flows, the elements of life are still present, waiting. Beneath the ice, the planet keeps its secrets, sleeping under layers of frost that have watched the sun rise and set for billions of years. If you were to stand at the edge of the northern cap, you might feel a quiet sense of reverence. Before you would stretch an expanse of white that could swallow entire countries, shimmering faintly under a thin orange sky. The cold would sting, but the view, endless and pristine, would feel strangely peaceful. In that moment, Mars wouldn't seem dead at all. It would seem patient, waiting for warmth, for discovery, for company. And perhaps that's what the polar caps really are. Frozen dreams, the remnants of a wetter, warmer Mars, preserved beneath crystal layers of time. They're the planet's memory made visible, a reminder that even after everything else has vanished, the rivers, the seas, the thick air, Mars still holds on to the hope of thaw. Mars is a planet of dust, not just a little, but oceans of it, drifting endlessly across its deserts and canyons. The same fine grains that give the world its warm red glow are also its most restless inhabitants. On a planet where air is thin and water scarce, dust has taken over as the main architect of weather. It sculpts dunes, paints skies, and sometimes, when the season is right, wraps the entire planet in a swirling veil of crimson haze. At first glance, it seems impossible that Mars could even have dust storms. The air is so faint, barely 1% as thick as Earth's, that a gentle puff of breath here would move more air than a Martian gale. Yet somehow that faint atmosphere manages to lift entire continents of dust into the sky. The secret lies in the nature of the dust itself. Martian dust is unbelievably fine, made of grains smaller than talcum powder. Once it's airborne, it stays there, suspended like smoke, scattering sunlight into a soft reddish glow that can last for weeks or even months. The smallest of these storms start as dust devils, tiny whirlwinds that dance across the plains like spinning ghosts. They form when sunlight heats the ground unevenly, causing pockets of air to rise and twist. On Earth we see them too, twirling through parking lots or desert flats, but on Mars they can tower kilometers high and leave long, dark tracks that stretch for many kilometers. Rovers like Spirit and Opportunity used to watch them drift by, sometimes lucky enough to have their solar panels cleaned by one. Each dust devil was both a spectacle and a small mercy, a swirling servant of entropy that happened to double as a cosmic janitor. But dust devils are just the beginning. As spring and summer bring more sunlight, convection currents strengthen, and local storms begin to grow. Pockets of warm air rise, carrying fine dust higher into the atmosphere. The particles absorb sunlight, warming the air further and fueling stronger winds. It's a self-feeding cycle. The more dust in the air, the warmer and windier it gets. Eventually, some storms join together, spreading across entire regions. In the right conditions, they can encircle the whole planet. The first time humans witnessed one of these global storms up close was in 1971, when the Mariner 9 spacecraft arrived at Mars. Instead of the clear, detailed landscapes scientists had hoped to see, they found a world completely smothered in haze. The storm had risen just days before the spacecraft's arrival, and had engulfed the planet so thoroughly that only the tips of the tallest volcanoes peeked through the murk. For weeks, Mars was a dim, featureless disk, a red planet turned pale gold. When the storm finally settled, it left behind a surface newly dusted, reshaped, and, in some places, rearranged entirely. Since then, nearly every orbiter and rover has experienced its own encounter with the Martian temperament. In 2018, a massive dust storm swept around the globe, blotting out the sun for months. The solar-powered rover Opportunity, which had been exploring the planet for 14 years, fell silent during that storm, its panels starved of light. When the skies eventually cleared, Opportunity did not wake again. Its final message, relayed through faint telemetry, was heartbreakingly simple. My battery is low and it's getting dark. That storm wasn't just a scientific event. It was a planetary drama, a reminder that even a thin sky can wield enormous power. Dust on Mars is more than decoration. It's a climate engine. Each storm redistributes heat, affecting global temperatures and winds. The suspended particles trap warmth from sunlight, temporarily raising the planet's temperature by several degrees. Then, when the dust settles, the surface cools again. These swings in temperature can shift atmospheric circulation, influencing everything from polar frost to small local breezes. In that way, Mars's dust storms act like a heartbeat, irregular but vital, pumping energy through an otherwise quiet world. And it's not just the atmosphere that feels their touch. Dust slowly coats everything. It blankets craters, fills valleys, and smooths jagged rocks into gentle forms. Over millions of years, it has softened the planet's appearance, blurring the sharp lines of ancient terrain. Even the colors we associate with Mars, the soft oranges, reds, and golds, come from thin layers of oxidized dust settling over darker volcanic rock. If you could sweep it away in one spot, the ground beneath might be black or grey, but the wind would soon erase your handiwork. Mars always reclaims its colours. There's an artistry to these storms too. Seen from space, they look like swirling brushstrokes painted across a dusty canvas. Wispy tendrils spiral over craters, golden clouds roll across plains, and shadows drift like smoke. In infrared images, you can watch waves of heat ripple across the surface, moving from sunlit to shadowed regions like slow-motion tides. It's mesmerizing, a ballet of dust and light performed on a planetary stage. For scientists, studying these storms isn't just about beauty. It's essential for understanding how Mars changes over time. The way dust absorbs and reflects sunlight helps determine how much heat reaches the surface. Dust also influences the planet's water cycle. When fine particles rise high enough, they can carry tiny ice crystals with them, forming high-altitude clouds. Some of those clouds, in turn, cool the surface and suppress further dust lifting, a delicate balance between chaos and calm. Yet despite decades of observation, predicting a Martian dust storm remains one of space science's great challenges. They can appear suddenly, with little warning, and their triggers aren't fully understood. Some years, the planet remains mostly clear. In others, it erupts into a frenzy of activity. It's as though Mars breathes irregularly, sometimes shallowly, sometimes with great dusty sighs. The very presence of so much dust raises deeper questions about Mars' past. Where did it all come from? The answer lies in erosion that never ends. Over billions of years, wind has ground volcanic rock into finer and finer particles. Without liquid water or vegetation to bind it, that powdery soil simply drifts. Impacts from meteors help too, crushing and churning the crust into an endless supply of airborne grit. Mars, in effect, is slowly erasing itself, turning stone into dust and dust into air. Even the rovers that explore the planet have become part of this slow transformation. Their metal wheels leave temporary marks in the soil, but within days, those tracks soften and fade. Instruments are designed with dust in mind, but it still finds its way into every joint and hinge, clinging electrostatically to surfaces. The thin atmosphere means there's no rain to wash anything clean, only wind to rearrange the dirt in new, unpredictable patterns. For future explorers, dust will be both an obstacle and a companion. It can clog filters, wear down seals, and reduce visibility, but it can also be harnessed. The fine grains contain valuable minerals and could even serve as shielding material, compacted into bricks to build habitats. Mars has no shortage of building supplies. It's just that most of them come pre-powdered. Standing on the planet during one of its calmer days, you might not even notice the dust at first. It drifts like fog, softening the light and turning the sky into a muted amber. But as the sun dips lower, the colours deepen. Shadows blur, horizons fade, and the world seems to dissolve into haze. Then with little warning the wind rises. A gust brushes past. Not strong, but persistent. You watch as fine sand begins to dance along the ground, forming small ripples that race away into the distance. Within minutes, visibility drops to almost nothing. The world becomes a whirl of reddish gold, and the sun shrinks to a pale disk behind a curtain of dust. Inside that storm the light would be strange, diffuse, almost dreamlike. The sky glows softly as if the planet itself is lit from within. The temperature drops, the air thickens slightly, and the only sound is a gentle, unending hiss. For all its power, a Martian dust storm is not deafening. It's quiet, a storm made of whispers. When the winds finally die down, the dust settles slowly like snowfall. The surface beneath emerges looking renewed, rippled dunes reshaped, rocks half buried, old rover tracks erased. Every storm gives the planet a new face, one painted in the same familiar palette of reds and golds. In the end, Mars remains what it has always been, a desert in motion. Its storms don't rage with fury so much as they breathe, rising and falling with the rhythm of sunlight and shadow. From tiny twisters to global veils, the dust connects every corner of the planet, binding land and sky in a single swirling dance. And there's something deeply poetic in that. A world once shaped by water, now sculpted by air, trading rivers for winds and waves for storms. The red mist may hide the surface, but it also reveals something quieter, the persistence of change. Even in stillness Mars moves, even in silence it whispers. Among all the sights that Mars offers, few are stranger or more haunting than the ones that appear after sunset. As the pale sun slips beneath the horizon, and the sky fades to a soft copper grey, two tiny moons emerge, Phobos and Deimos. They don't look like Earth's grand, glowing companion. Instead, they resemble misshapen stones, scuttling quickly across the heavens. They're so small and so close that they look more like shadows than celestial bodies, but their quiet presence adds a peculiar rhythm to Martian nights. Phobos, the larger of the two, is only about 22 kilometers wide, smaller than many earthly cities. Deimos is even tinier, barely 12 kilometers across. Both are irregular in shape, scarred by craters, grooves, and jagged edges that make them look more like asteroids than moons. In fact, that might not be far from the truth. For decades, scientists have debated whether these two bodies were captured asteroids from the outer solar system or fragments created when something enormous slammed into Mars long ago. If they were captured, the process must have been unusually gentle. Normally, a planet can't just grab a passing rock. It would either fling it away or smash it to pieces. To stay, the visitor must lose energy somehow, perhaps slowed by an ancient, thicker Martian atmosphere or a ring of debris that cushioned its fall into orbit. If they were born of collision instead, they might be the survivors of chaos, splinters left over from a moon-shattering impact that reassembled into two lopsided remnants. Whatever their origin, both moons tell a story written in dust and gravity. Seen from the Martian surface, Phobos dominates the sky. It orbits so close, only about 6,000 kilometers above the ground, that it appears more than twice as wide as our moon does from Earth. It moves fast, too, completing a full orbit in just 7.5 hours. That means it rises in the west and sets in the east, racing overhead several times each Martian day. If you stood on Mars, you could watch Phobos rise, cross the sky in 4 hours and set before night was even over. It's like watching a cosmic time-lapse happen in real time. Deimos, by contrast, is the quiet one. It orbits nearly 24,000 kilometers away, circling Mars once every 30 hours. To the naked eye, it would appear as a bright dot, just large enough to notice but too small to show detail. While Phobos darts like a restless bird, Deimos drifts gracefully, taking its time. The two moons are a study in contrasts, one in haste, the other in calm. Up close, they are worlds of remarkable oddity. Phobos is covered in grooves that run across its surface like scratches on ancient stone. Some scientists think these grooves formed from debris ejected during impacts, while others believe they're stress fractures, signs that the moon is slowly being pulled apart by Mars's gravity. Phobos orbits so close that it's caught in a slow spiral downward, inching closer to the planet every century. In about 50 million years, it will either crash into Mars or be torn to pieces, forming a ring that could encircle the planet like a dusty halo. It's a slow-motion tragedy on a cosmic timescale, a moon with an expiration date. Deimos, meanwhile, is drifting the other way, slowly escaping into space. Each year it moves a few centimeters farther from Mars. Someday it may slip beyond its planet's gravitational grasp entirely, wandering off as a lone traveler through the solar system. Together the two moons show opposite fates, one doomed to fall, the other destined to drift away. Phobos is also home to one of the most striking impact features in the solar system, Stickney Crater, a giant scar nearly half the moon's diameter. The collision that created it must have nearly destroyed Phobos outright. The force of that impact sent shockwaves through the entire body, leaving grooves and fractures that still line its surface. If you were standing near Stickney's rim, you could see almost the entire horizon curve around beneath you. The moon is that small. The sky would be filled with Mars, an enormous red sphere looming so close it would cover a quarter of the heavens. Sunlight reflected off Mars would bathe Phobos in a dim amber glow, so even its nights would never be completely dark. For astronauts someday exploring Mars, the sight of those two moons will be both comforting and uncanny. Phobos rises and sets so quickly that its shadow sometimes races across the surface, creating brief, localized eclipses. From orbiters and rovers, we've watched these tiny shadows glide silently over the landscape, perfect circles of darkness moving at breakneck speed. When Deimos passes in front of the Sun, it doesn't block it fully. It merely dims it slightly, like a cloud drifting across a pale star. Mars experiences eclipses too, but they're fleeting, blinks rather than nights. If you could watch from Mars's equator during a clear evening, you'd see Phobos climb rapidly above the horizon, speeding east to west. It would appear as a grey potato-shaped lump, mottled and rough, spinning slowly as it moves. You might even see faint streaks of dust trailing behind it, grains lifted from its surface by impacts and carried into a thin ring around the planet. Deimos would follow later, smaller and steadier, moving so gently it would seem almost still. Together they would make Mars's night sky feel alive, even in its vast silence. Phobos and Deimos have fascinated scientists and storytellers alike since their discovery in the year 1877 by the American astronomer Asaph Hall. Their names, taken from Greek mythology, mean fear and terror, the twin sons of Ares, the god of war. It's a fitting pair of companions for a planet named after Mars, their father's Roman counterpart. Yet their actual appearance couldn't be less frightening. They look humble, battered, and oddly endearing, cosmic pebbles accompanying a lonely world. Over the years, various missions have passed close to them, snapping photographs and measuring their shapes. The Mars Express orbiter from the European Space Agency has provided detailed 3D maps of Phobos, revealing its porous interior. It's not a solid rock, but a rubble pile held loosely together by gravity. Another reason it may one day crumble. Japan's upcoming mission, called Martian Moons E-Exploration, plans to visit both moons, collect samples, and bring them back to Earth. Those grains of ancient dust could finally answer the question of where these strange little worlds came from, whether they were born of Mars or merely captured by its gravity. There's something poignant about their smallness. Our own moon, bright and commanding, has been a symbol of romance, myth, and rhythm since humanity's beginnings. Mars's moons are different, modest, fleeting, and a little eerie. Yet in their quiet way, they're beautiful. They speak of the randomness of the universe, of how even broken pieces and wandering rocks can find companionship. On the surface of Mars, under its thin orange sky, the moons would move so quickly that they could be seen crossing the stars several times in one night. For future settlers, they might become familiar friends, Phobos marking time with its rapid rise and fall, Deimos keeping a slower rhythm in the background. Some might even measure their days by Phobos's passing, watching it climb and set like a heartbeat in the sky. It's humbling to think that someday people might stand on those tiny worlds themselves. On Phobos, the horizon would curve sharply beneath you, and the pull of gravity would be so weak that a single jump could send you dozens of meters into the air. If you looked down, Mars would dominate your view, a vast red disk filling the sky, clouded with dust and mystery. There would be no blue, no clouds, no oceans, just a silent planet glowing in reflected sunlight, its deserts stretching endlessly below. And there, in that eerie calm, you might understand something profound. These moons are reminders that even in the emptiest corners of the solar system, companionship endures. Phobos and Deimos, fear and terror, turned out to be nothing of the sort. They are the smallest of guardians, the quiet attendants of a lonely planet, circling endlessly through a sea of stars. Their orbits tell a story of impermanence and balance, of closeness and escape. They will not last forever. One will fall, one will flee, but for now they keep each other company, two tiny fragments of cosmic poetry dancing in the Martian night. Long before telescopes revealed a world of dust and silence, Mars existed in the minds of those who looked up and wondered. To the ancient eye, it was not a planet of science, but of story, a wandering red light that defied the quiet order of the stars. Where the others moved serenely, Mars seemed restless, changing brightness and colour, occasionally pausing in its course and even moving backward through the heavens. It was unpredictable, fiery and ominous, and so humanity gave it a name worthy of its strange behaviour: the planet of war. The earliest recorded observers of Mars were the Babylonians, sky watchers so meticulous they could predict planetary movements centuries ahead. To them, Mars was known as Nergal, the god of destruction, pestilence, and fire. His crimson glow was seen as the colour of burning cities in the heat of battle. The Babylonians kept careful tablets noting its path through the constellations, believing that where it travelled, misfortune followed. A bright Mars near certain stars meant famine, a dim Mars signalled plague. To them, it wasn't just an object in the sky, it was a messenger, a divine omen written in light. The ancient Egyptians saw Mars differently. They called it Her-de-Cher, meaning the Red One, a simple name that captured both its colour and its mystery. The Egyptians noticed that Mars sometimes slowed down, reversed, and then resumed its motion, an optical illusion we now know as retrograde motion. To them, it was as though the god had paused to consider something, perhaps a judgment, before continuing on his way. In some depictions, Mars was associated with Horus the Red, an aspect of the falcon-headed sky god, fierce and sharp-eyed. Its movements were woven into their calendar and their understanding of cosmic balance, proof that even the heavens could hesitate. The Greeks, who gave us the term planet itself, meaning wanderer, were captivated by Mars' unpredictable dance. To them, it was Ares, the god of war and bloodlust, son of Zeus and Hera. Unlike Athena, who represented strategy and wisdom in battle, Ares embodied pure chaos, the noise and fury of conflict without reason. When they looked up and saw that bright reddish point wandering through the constellations, they saw the reflection of Ares himself, eternally roaming and restless. For the Greeks, this colour in the sky wasn't just an astronomical curiosity. It was the visible heartbeat of divine conflict. The Romans later inherited this vision and gave it a name that has endured ever since: Mars. In their mythology, Mars was not only a god of war but also of agriculture and fertility, a more complex and noble figure than his Greek counterpart. To the Romans, war was not merely destruction, but a means of securing peace and prosperity. The reddish planet became his celestial domain, a fiery token of strength and endurance. Soldiers invoked Mars for courage, farmers for fruitful harvests, and emperors for victory. It's easy to imagine Roman legions marching under banners of crimson cloth, believing that the glow above them was the watchful eye of their patron deity. Mars's blood-red glow was so distinctive that even cultures far from the Mediterranean found meaning in it. The ancient Chinese called it the fire star, and placed it among the 5 planets of traditional astronomy, each tied to one of the classical elements: wood, fire, earth, metal, and water. Its presence in the night sky was considered an omen of upheaval and change, especially when it appeared near the constellation associated with the emperor. Court astrologers watched it closely, fearing that its wandering path foretold rebellion or disaster. The emperor's advisors sometimes delayed major decisions until Mars had moved to a more auspicious place, hoping to outweight its fiery temper. In Hindu astronomy, Mars is known as Mangala, a celestial being both auspicious and fierce. Mangala is the god of war and celibacy, embodying strength, courage, and discipline. He rides a ram, his colour red, and his energy hot and decisive. In Vedic astrology, his position in a person's birth chart is said to influence their passion and aggression, their capacity for leadership or conflict. A strong Mars means vitality and drive, a weak one, hesitation and doubt. Even here, half a world away from Greece and Rome, the red planet carried the same dual spirit, both creative and destructive, a symbol of life's burning energy. The ancient peoples of the Americas too watched the Red Wanderer with reverence. The Mayans recorded its movements with remarkable precision, weaving them into their complex calendar systems. To them, Mars's retrograde motion represented cycles of conflict and renewal, a cosmic battle fought in the heavens that echoed in the affairs of kings and warriors below. In many ways, their view was not so different from the Babylonians or Romans. Mars was the reflection of human struggle written in starlight. What's remarkable is how universally Mars inspired both awe and anxiety. Across continents and centuries, civilizations that never met each other all agreed on one thing: the red planet was alive with meaning. Its glow was too striking to ignore, too distinct to mistake for any other. Night after night, its colour conjured the same associations: fire, blood, war, and vitality. In a universe that otherwise seemed calm and eternal, Mars was motion itself, the one that refused to sit still. Even after the telescope revealed its true form, the mythology never quite faded. When early astronomers began sketching Mars in the 17th century, they saw dark patches and pale caps that seemed almost alive. By the late 19th century, as better lenses revealed faint lines crossing the planet's surface, imagination filled the gaps once more. Giovanni Schiaparelli called them canali, channels, but the word was mistranslated as canals, sparking dreams of an intelligent Martian civilization. Suddenly, Mars was not just a god of war, but a world of builders. The stories shifted from divine conflict to interplanetary curiosity, yet the fascination remained the same. Writers and dreamers picked up where the myth-makers had left off. H.G. Wells imagined Martians invading Earth in The War of the Worlds, flipping the narrative of conqueror and conquered. Edgar Rice Burroughs wrote of a romantic Mars filled with adventure and strange civilizations. The red planet became the stage for human imagination, part battlefield, part frontier. We stopped fearing Mars as an omen in the sky, and started longing for it as a destination. The mythology evolved, but it never truly disappeared. It simply traded temples for telescopes. In every age, Mars has mirrored the concerns of humanity. To the Babylonians, it was divine anger. To the Romans, disciplined power. To modern science, a world of potential life and loss. Each interpretation reveals more about us than it does about the planet itself. Perhaps that's why Mars still feels strangely personal. It's the only other world that seems to share our temperament: beautiful, barren, volatile and yearning. Imagine an ancient night long before city lights, when the stars were sharp and the world was still. Somewhere, a shepherd or priest or soldier looks up and sees that red light burning in the sky. They can't name it, can't measure it, but they feel its presence. They sense that it means something, that it's watching, that it carries both promise and danger. Thousands of years later, we know the chemistry behind that glow. Iron oxide reflecting sunlight through a thin atmosphere. But somehow, the knowledge doesn't erase the feeling. Even now, when we see Mars rise, bright, steady, and a little too red, it still evokes something ancient. The myths may have softened, the gods may have fallen silent, but the emotion remains. The planet that once stood for war and destruction now stands for curiosity and exploration. Yet both impulses spring from the same place: the desire to understand what burns beyond reach. Mars has journeyed from mythology to science, from fear to fascination, but in every form it has held a mirror to our imagination, and perhaps that's its truest role, not as a god or a world to conquer, but as a reflection of ourselves, glowing quietly in the darkness, forever inviting us to look up and wonder what it means. For most of human history, Mars was a mysterious red light in the sky, distant, untouchable, and alive only in myth. But by the 19th century, telescopes had transformed that mysterious glow into a visible world. Craters, shadows, and pale polar caps began to appear under the glass. And with those first blurred glimpses, something extraordinary happened. The line between observation and imagination began to blur as well. The story begins in the late 1800s, when astronomers were pushing the limits of what small ground-based telescopes could reveal. Among them was an Italian named Giovanni Schiaparelli, the director of the Brera Observatory in Milan. During the Great Opposition of 1877, a time when Mars swung unusually close to Earth, Schiaparelli trained his telescope on the planet and saw faint, thread-like markings crossing its surface. He called them canali, an Italian word meaning channels. It was an innocent choice of words, meant to describe something natural, like river valleys or grooves. But when his reports were translated into English, canali became canals, a very different term, one that implied deliberate construction. Suddenly, Mars was no longer just a dry, lifeless rock. It was a world of engineers. The idea spread like wildfire. Newspapers, scientists, and dreamers all seized on it. If there were canals, then there must be water, and if there was water, then surely there was life. The notion of intelligent Martians building vast waterways to irrigate a dying planet took hold of the public imagination. Astronomers around the world began peering through their own telescopes, trying to confirm what Schiaparelli had seen. Some did, or thought they did. Others, seeing nothing of the sort, blamed poor conditions or inferior instruments. The debate grew almost philosophical. Was it possible that some observers could see more clearly simply because they believed more deeply? In hindsight, it seems clear that the canals were optical illusions, born from the eye's natural tendency to connect faint, patchy features into lines. But at the time, the evidence was ambiguous enough to leave plenty of room for wonder. No one championed the idea of Martian canals more passionately than Percival Lowell, a wealthy American astronomer and polymath. Inspired by Schiaparelli's sketches, he built his own observatory high in the clear air of Flagstaff, Arizona, specifically to study Mars. Over the next 2 decades, Lowell mapped what he claimed were hundreds of canals, an intricate planet-spanning network, symmetrical and precise. He even proposed that they change with the seasons, darkening as water flowed through them, perhaps drawn from melting polar caps. To Lowell, this wasn't speculation, it was civilization. He imagined a dying world, its oceans long vanished, where intelligent beings had turned to engineering to survive. They had built a system of canals to transport the remaining water from the poles to the equator, keeping their planet alive for just a little longer. It was a romantic vision, equal parts melancholy and triumph. And for the public, it was irresistible. Lowell's ideas found their way into magazines, lectures, and newspapers. The world fell in love with the notion of Martians, not monsters, but desperate dreamers fighting against extinction. Science and storytelling intertwined. H.G. Wells took the darker route, imagining the Martians of the War of the Worlds as invaders seeking refuge on Earth. Edgar Rice Burroughs chose adventure, creating the swashbuckling John Carter of Mars. Even Nikola Tesla claimed he might have detected radio signals from Martian civilization. For a brief moment, the red planet was humanity's mirror, a world that reflected both our fears and our hopes. Yet not everyone was convinced. Many astronomers struggled to see what Lowell claimed was obvious. When larger telescopes with better optics became available, the famous canals seemed to vanish. In their place were patches and streaks, natural features that shifted subtly with light and atmosphere. Some scientists suggested that Lowell's mind, keen and imaginative as it was, had played a trick on him, connecting dots into patterns that weren't there. It's a very human error, and perhaps one of the most poetic in all of science. By the early 20th century, new photographs of Mars taken through observatories in America and Europe showed no sign of canals at all. The myth began to crumble, but even as the evidence faded, the fascination didn't. The image of a dying Mars, clinging to life through intelligence and ingenuity, had already sunk into our collective imagination. It wasn't just an astronomical mistake. It was a cultural moment, the first great science fiction dream born from the telescope. When spacecraft finally reached Mars in the 1960s, they brought answers that were both sobering and awe-inspiring. NASA's Mariner 4 flew past the planet in 1965, sending back the first close-up images. There were no canals, no gleaming cities, only craters, plains, and the quiet scars of an ancient world. Yet even in that desolation, scientists found something profoundly beautiful. A planet shaped by forces familiar and strange. A world with its own history written in dust. The disappointment of the vanished canals didn't end humanity's obsession with Mars. It transformed it. The fantasy of intelligent Martians gave way to a deeper curiosity about the planet's real nature. If not canals, then what carved the valleys? If not civilizations, then what about microbes? What could the chemistry of its rocks tell us about its past? The myth of the canals may have been wrong, but it led us to ask better questions. Looking back now, the story of the Martian canals feels almost quaint, but it captures something timeless about human nature. When faced with uncertainty, we fill the gaps with imagination. We want the universe to be alive, to talk back. The canal dream was our way of reaching across space and asking, are we alone? And though the answer turned out to be silence, the question still echoes today, in every rover that rolls across Martian soil and every satellite that listens for whispers from the dust. In a strange way, the canal craze also changed how science communicates with the public. It was one of the first times astronomy truly captured the world's imagination on a global scale. People gathered in lecture halls, read serialized reports, and debated over breakfast whether Martians were real. It was the beginning of popular science, proof that discovery, even when mistaken, can unite wonder with reason. Even now there's a certain charm to those hand-drawn maps. Neat lattices of dark lines traced across a red sphere, human fingerprints on cosmic mystery. They remind us that exploration is not only about accuracy, it's also about curiosity. The dreamers who saw canals were not fools. They were people daring to see meaning where there was only blur. They looked through shaky lenses and imagined civilization, and in doing so they taught us that imagination and evidence are both essential to discovery, one to reach, the other to verify. If you were to stand on Mars today and gaze up at the pale pink sky, you'd see no canals, no cities, no lights flickering in the dust. But you might smile at the thought that once, people on another world looked at this same horizon and believed that someone was looking back. And perhaps that belief, however mistaken, was the first step toward making the connection real. The red planet taught us a quiet lesson through its illusion, that wonder can outrun certainty, and that's not always a bad thing. The canals may have been an error, but they led us to exploration, to spacecraft, to rovers, and to the enduring question of whether life, any life, ever touched those sands. In the end, the truth turned out to be even more profound than the dream. There were no Martian engineers, no vast waterways, But there was a world, ancient and intricate, waiting patiently for us to see it clearly, and that, in its own way, is just as miraculous. Long before a human ever set foot on Mars, our machines went first, small, patient ambassadors of curiosity. They went without hearts to beat or lungs to breathe, but they carried our hopes in circuits and solar panels, whispering back their discoveries through the dark. These robotic pioneers have been our eyes and hands on a distant desert, quietly exploring a world that still seems to hold its breath. The story begins in the 1960s, when Mars was still a mystery glimpsed only through telescopes. For centuries, people had argued about canals and civilizations, but no one had seen the planet clearly. Then, in 1965, NASA's Mariner 4 changed everything. It flew past Mars at more than 11,000 kilometers per hour, snapping 21 photographs, grainy, black and white glimpses of craters and plains. The images shocked the world. Mars wasn't a lush world of alien canals, it was a cold, cratered desert, eerily similar to the Moon. Yet, for all its bleakness, it was beautiful. Those pictures marked humanity's first true encounter with another planet's surface. Mariner 4 was followed by Mariner 6 and 7, which refined the view, sending back dozens more images and data on the thin carbon dioxide atmosphere. Each mission peeled back a layer of myth and replaced it with evidence. Finally, in 1971, Mariner 9 became the first spacecraft to orbit another planet. When it arrived, the world it found was hidden beneath a global dust storm, turning Mars into a pale orange sphere. For months, it waited patiently until the haze began to clear. What it revealed changed everything once again. Vast canyons, extinct volcanoes, dried river channels. It was the first time we saw Olympus Mons towering above the horizon and Valles Marineris stretching like a scar across the equator. Mariner 9 turned a lifeless world into a landscape. It showed that Mars was not simply a frozen relic, but a planet that had once been alive with geological energy. Its legacy was profound. It taught scientists to see Mars as dynamic, not dead, and inspired the next generation of missions that would reach out not just to look, but to touch. In 1976, that next step arrived. The twin Viking landers, Viking 1 and Viking 2, descended onto the Martian surface, becoming the first successful missions to land and operate on another planet. Each lander carried cameras, weather instruments, and biology experiments designed to search for signs of life. The first images they sent back stunned the world. A rocky plain under a salmon-pink sky, with a distant horizon fading into haze. For the first time in history, we were standing, in spirit, on Mars. Viking's experiments tried to detect metabolism in the soil, hoping to find evidence of microbes. The results were puzzling. Some tests gave hints of activity, others didn't. Scientists debated for decades whether Viking had stumbled upon life or just the chemical quirks of a harsh environment. But the uncertainty didn't diminish the achievement. Viking proved we could land safely, survive the cold, and send back clear, stunning images of a world once thought unreachable. Its cameras captured sunsets, frost, and even the thin outlines of dust devils drifting across the horizon. For the next 2 decades, Mars fell silent again. After Viking, no spacecraft landed successfully until the late 1990s. The technology was difficult, the costs high, and the planet itself, with its thin air and unpredictable winds, unforgiving. But in 1997, a small, plucky mission rekindled our connection. Pathfinder and its tiny rover, Sojourner. It was only the size of a microwave, yet it made history. Sojourner trundled across the rocks of Ares Vallis, taking colour photographs and analysing stones with its simple instruments. The rover's slow, cautious movements were broadcast around the world, capturing hearts as much as data. It wasn't just exploration, it was personality. From that point onward, Mars exploration entered a golden age. In 2004, two twin rovers, Spirit and Opportunity, landed on opposite sides of the planet, each tasked with exploring for 90 days. They lasted far longer. Spirit roamed for 6 years, and Opportunity, astonishingly, for nearly 15. Together they became explorers in the truest sense, navigating craters, climbing hills, and examining the mineral clues left behind by ancient water. Spirit's cameras revealed layered rocks that had once been shaped by liquid water, and Opportunity found tiny spherical blueberries, mineral deposits formed in wet conditions. Those discoveries confirmed what scientists had long suspected. Mars had once been a world with lakes, rivers, and perhaps even seas. For the first time, we weren't just studying a barren planet, we were uncovering its history. The two rovers developed a sort of legend of their own. They weren't just machines, they became symbols of persistence. Spirit eventually became stuck in soft soil in 2009, sending data until its power ran out. Opportunity continued its lonely trek across the plains of Meridiani for almost another decade. When a massive dust storm enveloped the planet in 2018, the rover's solar panels were smothered. After months of silence, NASA sent one final message. "My battery is low and it's getting dark." Opportunity never replied. It was a strangely human ending, poetic and heartbreaking. A goodnight whisper to a faithful explorer. By then, Mars had new companions. In 2012, the Curiosity rover touched down inside Gale Crater, lowering itself onto the surface via an extraordinary sky crane system. It was the most complex landing ever attempted. Part engineering miracle, part controlled free fall. Against all odds, it worked flawlessly. Curiosity was much larger than its predecessors, about the size of a small car, and equipped with a laboratory capable of analyzing rocks, soil, and air with astonishing precision. Curiosity's mission was not just to find water, but to ask a deeper question. Could Mars ever have supported life? The answer it found was yes, at least in the distant past. The sediments it examined revealed evidence of neutral water, organic molecules, and conditions that would once have been habitable. It even carried an instrument to sniff the air for methane, a potential sign of life. Occasionally it detected faint whiffs of the gas. Enough to intrigue, never enough to confirm. Each discovery felt like another breadcrumb leading deeper into Mars's ancient mysteries. Then came Perseverance, which landed in 2021 inside Jezero Crater, a site that once held a river delta. Unlike Curiosity, Perseverance carries the tools to begin something monumental, collecting and caching rock samples for a future return to Earth. Those samples may one day hold the first clear evidence of whether life ever existed on another planet. Perseverance also brought a little companion, Ingenuity, a small helicopter designed to test flight in the thin Martian air. Against all expectations, Ingenuity flew again and again, each time rising above the dusty surface and proving that even on a world where air is almost nothing, lift is still possible. Watching Ingenuity's first flight was like seeing a miracle in miniature, a fragile machine dancing on a planet where human feet have never touched. It marked the first powered flight on another world, a tiny step that opened vast possibilities for future exploration. Each of these missions, from Mariner to Perseverance, has built upon the last, not in haste, but in quiet determination. They've taught us how to navigate alien skies, survive dust storms, and read the language of rocks written billions of years ago. Together they've transformed Mars from a distant light into a world we almost know. And yet, for all their triumphs, There's something movingly lonely about these robotic explorers. They operate in silence, in a place where wind barely whispers and sunlight feels thin. When their cameras turn toward the horizon, we see not just the surface of another planet, but the reflection of human longing, our desire to reach beyond, to understand, to leave gentle footprints even where we cannot go ourselves. If you look at a photograph from Spirit or Curiosity, you can almost feel that quiet. The empty plains stretch to the horizon, rocks cast soft shadows, and the sky glows pale orange. No voices, no motion, just the patient gaze of a machine doing what we built it to do, to see for us. Each rover, each orbiter, is a mechanical pilgrim, wandering across time and distance on our behalf. Mars, once the planet of myth, became the planet of machines, and those machines, though they have no heartbeat, carry something of our own, a sense of wonder, of persistence, of optimism that refuses to fade. They are our scouts in the dark, our first emissaries to a world that has waited for billions of years to be noticed. And perhaps someday, when humans finally arrive, they'll find the tracks of these small explorers still etched in the dust, silent monuments to a time when curiosity itself was our greatest engine. For centuries Mars was the silent planet, a world that could be seen but never heard. Through telescopes we could trace its colours, sketch its canyons and watch its storms, but there was no sense of what it might sound like to stand there. Silence, we assumed, was all there could be. But when our machines began to land and listen, that silence turned out to be filled with whispers, faint, delicate sounds that told stories the eyes alone could never see. Sound travels differently on Mars. Its atmosphere is thin, less than 1% the density of Earth's, and made mostly of carbon dioxide. That means sound waves don't move through it the same way they do here. On Earth, when you clap your hands, air molecules bump into each other quickly, passing vibrations along in a neat, dense chain. On Mars, the air molecules are so far apart that sound struggles to move. It travels slower, dies out sooner, and changes pitch in strange ways. High-pitched sounds fade almost instantly. Only the lower, deeper ones survive. Even if you shouted, the words would be muffled as though you were speaking underwater. It wasn't until the 21st century that humanity finally heard what Mars truly sounded like. The first hints came from instruments that weren't designed as microphones at all, sensors that picked up vibrations through the air and ground. But the real breakthrough arrived in 2019, when NASA's InSight lander deployed a seismometer on the Martian surface. Its purpose was simple but profound: to listen for quakes. And what it found was that Mars, though quiet, is not still. InSight recorded the faint thuds of Mars quakes, tiny tremors rolling through the crust, shaking the dusty plains of Elysium Planitia. The sounds were barely audible, far below what human ears could detect unaided. But when the data was converted into sound waves, something extraordinary emerged. A low, hollow rumble, like the creak of a vast wooden ship in the dark. It was the voice of the planet itself, deep and ancient. Each quake revealed something new about Mars's interior. The thickness of its crust, the density of its core, the secrets of how it cooled over time. For the first time, we weren't just seeing Mars, we were feeling it. The seismometer also picked up other kinds of vibrations, not just quakes, but the movements of the wind. As gusts brushed against the lander's solar panels, they sent ripples through the thin air, making the instruments hum faintly. When scientists converted those ripples into sound, they were astonished. It was soft, ghostly, but unmistakably real. The sound of Martian wind. It wasn't a roar or a howl like Earth storms, more like a breath, a steady exhale across a barren plain. In that faint whisper, listeners around the world suddenly felt the distance between planets shrink. When the Perseverance rover landed in 2021, it carried microphones designed specifically to record sound on Mars. The first thing they captured was not wind, but the rover itself, the whir of motors, the crunch of wheels on gravelly soil, the clatter of mechanisms unfolding after landing. It was in a way the sound of human presence in a place that had never known it before. Then, after the noise quieted, the microphone caught something else. The breeze. A soft hiss. The flutter of dust against metal. The planet's breath brushing against our machine. For the first time in history, we were hearing another world's weather in real time. Those recordings were played around the world, brief simple clips lasting just seconds, yet they carried a weight that no image could match. They reminded us that sound is intimacy. We can look at pictures of distant places and admire them, but to hear them, even faintly, is to feel as though we're standing there ourselves. The thin air, the soft winds, the faraway rumble of the ground. Together they paint a sensory portrait of a world that has waited billions of years for an audience. The microphones also revealed how strange Mars truly is. Because the atmosphere is so thin, two sounds played at once can reach your ears at different times. A high note might lag behind a low one, as though the air itself can't quite keep up. InSight's instruments once detected the faint ping of a meteorite striking nearby, the first time such an impact had ever been heard on another planet. The sound, once processed, came across as 3 quick pops, followed by an eerie descending tone as the waves bounced off the Martian surface. It was brief and distant, but it proved something extraordinary. Even on a world so far away, you can still hear the universe at work. Mars has its own kind of music, not in melody, but in rhythm. The rumble of quakes, the pulse of wind, the soft crackle of dust moving across rock. Scientists studying the acoustic environment there have learned that wind is often the loudest sound on the planet, but even that is subdued. When Perseverance's microphones record a dust devil passing nearby, it sounds like a heartbeat of the landscape. A gentle rise in volume, a short burst of sand, and then quiet again. Its weather is percussion, subtle but constant. Each sound tells us something about the atmosphere too. The pitch and timing of a gust can reveal wind speed, while echoes from the rover's own mechanical noises help map the density of the air. Engineers even use these sounds to monitor the health of the rovers, listening for changes in the whir of gears or the hum of pumps. Mars, it turns out, speaks to those who know how to listen. And there's poetry in that. For so long we thought of Mars as a silent desert, but it was only silent because we hadn't yet learned its language. Now, with microphones and seismometers and weather stations, we're beginning to understand it. The planet hums, sighs, and occasionally murmurs, not in words, but in patterns. Every vibration is a sentence, every tremor a paragraph in a story 4 billion years long. The atmosphere itself is an instrument, tuned to different notes than Earth's. When a rock falls, its sound is softer, lower, stretched out. When the rover fires its laser at a stone to study its composition, you can hear a sharp snap, the pop of vaporizing dust. The time delay between the laser firing and the sound reaching the microphone helps measure the air's temperature and density. Even silence becomes meaningful. It tells us how empty, how vast, how delicate this world really is. For the teams who operate these missions, listening has become as important as seeing. The wind sigh helps calibrate sensors. The quake's rumble maps the unseen interior. Every tone, no matter how faint, carries data. But beyond the science, there's something deeply human in those recordings. When you hear the Martian wind through your headphones, a thin, whispering current brushing against alien metal, You're not just hearing air moving. You're hearing distance, history, and connection all at once. It's a strange thought that sound, so ordinary here on Earth, is a rare and fragile thing elsewhere. On Mars it fades quickly, struggling to cross even a few meters. And yet, that fragility makes it precious. Each faint rumble or breath of air is a reminder that Mars is not dead, it's simply quiet. It still shifts, quakes, and sighs under the weight of its thin sky. It's a planet with a pulse, subtle and steady. So, when the next recording arrives, a short clip of wind or the distant echo of a meteorite landing, take a moment to listen closely. That faint whisper is more than just noise. It's the sound of another world existing right now, turning under the same sun as ours. It's the voice of a desert that has waited for billions of years to be heard. And now, thanks to the patient ears we've left there, Mars finally has someone to listen. Of all the questions Mars has ever inspired, one has lingered the longest and weighed the heaviest. Is it alive? Not alive in the way we are, not with forests or animals or bustling cities, but in the smallest, most delicate sense. Could something once have swum in its ancient rivers, or might something even now cling to the underside of a rock, hidden from the cold and the light? For more than a century, that question has driven both science and imagination, keeping humanity's gaze fixed on a little red dot that refuses to give up its secrets. The search for life on Mars began long before spacecraft or rovers, when astronomers first thought they saw evidence of intelligent design, those famous canals drawn across the planet's surface. Though we now know they were illusions, the idea that life might exist on another world had taken hold. It was a thrilling and terrifying notion at once. For the first time, people considered that we might not be the only living thing in the universe. That idea didn't fade with better telescopes, it only evolved. By the middle of the 20th century, scientists were no longer talking about Martian civilizations, but microbes, tiny, hardy organisms that might have found a way to survive in that cold desert air. The first real test came in the year 1976, when NASA's twin Viking landers touched down on the Martian surface. Each carried a small suite of biology experiments, carefully designed to answer that ancient question. The Viking team wanted to know whether there was any sign of metabolic activity in the soil, chemical reactions that might hint at life. They scooped up samples, added nutrients, and waited to see if gases would be released. At first, the results were astonishing. One experiment detected bursts of oxygen, as though the soil were indeed breathing. But the excitement didn't last. Other instruments found no organic molecules at all. Nothing that would support biology as we know it. The Viking data sparked decades of debate. Were those oxygen readings evidence of metabolism, or were they simply chemical reactions caused by ultraviolet radiation on the surface? The Martian soil, it turned out, was far more reactive than anyone had expected, filled with oxidizing compounds that could mimic life's chemistry without being alive. The cautious conclusion was that Viking had found no proof of life, but the ambiguity never went away. Some researchers still wonder if perhaps the mission's sterilization methods or the intense heat of the analysis chambers destroyed what little evidence there was. Others believe the signals were purely chemical, a false alarm in a world where chemistry sometimes behaves like biology. For a while, the question of life on Mars went quiet. Missions shifted focus from biology to geology, studying the planet's surface and climate instead. But every new discovery seemed to circle back to that same question. When orbiters and rovers began finding evidence of ancient riverbeds, lake basins, and minerals that form in water, the conversation reignited. If Mars had once been wet, could it also have once been alive? By the early 2000s, that question grew louder again when NASA announced a startling find. tiny structures inside a Martian meteorite known as ALH 84001. The rock had been blasted off Mars by an ancient impact and eventually landed in Antarctica, where it was discovered in 1984. When scientists examined it under an electron microscope, they saw what looked like microscopic fossils, elongated, worm-like shapes embedded in the stone. For a brief, dazzling moment, it seemed that life on Mars had finally revealed itself. President Bill Clinton even addressed the nation, calling it a discovery that speaks of the possibility of life beyond Earth. But, as often happens in science, enthusiasm gave way to caution. Other researchers soon showed that the shapes could have been formed by non-biological processes. The meteorite remains fascinating. It really did come from Mars, but its structure's now thought to be geological rather than biological. Still, the excitement of that moment reminded everyone just how much we want Mars to be alive, and how easily our hopes can outpace the evidence. Since then, the search has become more careful, more precise, and more grounded in chemistry than in wishful thinking. Modern rovers like Curiosity and Perseverance are not equipped with test tubes or Petri dishes, but with tools that can identify complex organic molecules, the raw ingredients of life. When Curiosity drilled into ancient mudstones in Gale Crater, it found traces of carbon compounds preserved in the rock, alongside sulfur, nitrogen, and phosphorus. These are the building blocks of biology. They don't prove life existed, but they prove the planet once had the right chemistry for it. Then came an even more mysterious clue: methane. On Earth, most methane comes from living things, microbes, decay, digestion, and other biological processes. When Curiosity detected tiny puffs of methane in the Martian atmosphere, scientists were intrigued. The amounts were small and fleeting, appearing and disappearing with the seasons. Some orbiters confirmed the signal, others couldn't find it at all. The debate continues today. The methane could come from geological processes, perhaps reactions between water and certain rocks deep underground. But it could also, in principle, come from microbes sealed beneath the surface. For now, it remains an open mystery, one that hints tantalizingly at hidden activity beneath the quiet dust. Part of what makes the search so difficult is Mars itself. Its surface is harsh and sterilizing, bathed in ultraviolet radiation and cosmic rays. If life exists today, it would have to be buried deep underground, where liquid water might still persist in salty brines. That's why current and future missions are designed to look beneath the surface, drilling into rocks, studying crater walls, and examining mineral veins that may have once carried groundwater. Perseverance, for example, is collecting samples from the delta of an ancient river in Jezero Crater, a place where sediment once settled out of flowing water. Those samples, sealed in small tubes, will one day be brought back to Earth. When they arrive, scientists will study them with instruments far more sensitive than anything we could ever send to Mars itself. Inside those rocks could lie the faint chemical traces of life, or proof that Mars has always been alone. But even if the answer turns out to be no, that doesn't make the search any less meaningful. The question of whether Mars is alive reaches beyond biology. It touches philosophy. It forces us to consider what life really means. Does it require movement, metabolism, and reproduction? Or can it be something more subtle, a flicker of chemistry that nearly crossed the threshold? If we find nothing alive on Mars, it might teach us how rare and precious life truly is. And if we find even a single fossil microbe, or a preserved chain of organic molecules that could not have formed by chance, it will change everything we know about ourselves. It would mean that life is not a miracle unique to Earth. It's a natural part of the universe, waiting wherever conditions allow it to spark. There's something deeply human about how we approach this search. Every rover that digs, every orbiter that scans, every scientist who spends decades analysing dust is driven by the same quiet question that began with Schiaparelli's telescope and Viking soil samples. What if we're not alone? We've learned to temper our excitement, to demand evidence before belief, but the wonder remains. Even the faintest hint of organics in a Martian rock can send hearts racing, because in that dust might lie the story of a second genesis, proof that life found a way twice within one small solar system. Mars has become a kind of mirror for our curiosity. We project onto it our hopes, our methods, and our longing to connect with something beyond ourselves. Its surface is dry, but our imagination floods it with possibilities. Whether or not we find microbes there, the act of searching, of listening for life's faintest echo across millions of kilometers, is itself a profound expression of life. Perhaps one day a future scientist on Mars will hold a microscope slide up to the light and see something move, a flicker, a shape, a cell. Or perhaps all we will ever find are the chemical ghosts of what might have been. Either way, the question has already transformed us. The search for life on Mars has taught us patience, humility, and wonder. The three traits any living world, however small, would surely recognize as signs of intelligence. For as long as Mars has filled the night sky, people have wondered what it might be like to stand there, to feel its wind, to walk its deserts, to call it home. And for almost as long, there's been an even bolder idea drifting through scientific dreams. What if we could make Mars more like Earth? The thought has a quiet, irresistible pull. To take a frozen, silent planet and breathe warmth into it again. To turn a world of ice and dust into one where rain might fall. It sounds like science fiction, and in many ways it still is. Yet, hidden beneath the poetry, there is real science, an equally real challenge. The concept is known as terraforming, literally earth-shaping. It's the idea of altering a planet's environment until it could sustain life, or even human settlement, without heavy machinery and sealed suits. Mars has always been the leading candidate. It's the most Earth-like world in the solar system. Small, but with days only 40 minutes longer than ours, seasons shaped by a similar tilt, and a landscape of mountains, valleys, and polar ice caps. It's close enough to feel possible, but that word, possible, hides a mountain of difficulty. At its heart, terraforming Mars would mean doing three things: warming the planet, thickening the air, and restoring liquid water. Each of those tasks sounds simple when said aloud, but every one of them brushes against the edge of what we can currently do even here at home. Mars is cold because its atmosphere is thin, and its distance from the sun leaves it with less than half the sunlight Earth receives. The first challenge, then, is heat. Some scientists have suggested that if we could release the carbon dioxide trapped in the planet's soil and polar caps, we might create a greenhouse effect. The idea is to melt the carbon dioxide ice at the poles, letting it evaporate into the air. The thicker atmosphere would then trap more heat, which would melt more ice, which would release more gas. A chain reaction that could, in theory, warm the planet gradually. But the numbers are sobering. Studies show that even if we released all the carbon dioxide currently frozen on Mars, the pressure of the new atmosphere would still be less than 1% of Earth's. The greenhouse effect would barely lift the temperature. To truly warm the planet, we'd need to import or manufacture trillions of tons of additional gases, an engineering task beyond anything humans have ever attempted. Some have proposed producing powerful greenhouse gases like perfluorocarbons, which could trap heat far more effectively than carbon dioxide. But creating enough of them would require entire industries operating on a planet that can barely support a single outpost. Others have suggested more imaginative solutions. We could build vast orbital mirrors, gigantic reflective sheets that focus sunlight onto the poles, melting the ice directly. Or we could bombard the atmosphere with hydrogen-rich asteroids to release water and heat. A few have even wondered if controlled nuclear explosions might help thaw the poles, though the practical and ethical problems of such an approach make it unlikely. Each idea shows a spark of brilliance, and each collapses under the sheer scale of the task. The energy required to warm an entire planet is beyond anything humanity has ever mustered. Even if we solve the temperature problem, we would still need air. The Martian atmosphere today is thin, dry, and made almost entirely of carbon dioxide. There's no breathable oxygen, and too little nitrogen to act as filler. The thin air cannot hold pressure, which means any unprotected liquid water would simply boil away. To fix that, we would need to find a way to release gases from the rocks, oxygen from oxides, nitrogen from minerals, or bring them from elsewhere. That might mean redirecting icy comets, mining Saturn's moon Titan, or creating atmospheric factories that split gas molecules atom by atom. It's a process that would take centuries, maybe millennia. And then there's the question of magnetism. Earth's atmosphere is protected by its magnetic field, a shield generated by the movement of molten iron in its core. Mars lost its magnetic field billions of years ago, leaving its atmosphere exposed to the solar wind, the constant stream of charged particles from the sun that strips gases away over time. Even if we managed to give Mars a thick atmosphere again, it might not last. Without protection, the air would slowly erode back into space, leaving the planet just as bare as before. To solve that, one bold idea suggests placing an artificial magnetic shield at a point in space between Mars and the Sun, a massive satellite generating a field strong enough to deflect solar radiation. In computer models, it works beautifully. In practice, it would be one of the most complex engineering projects ever conceived. But in the spirit of imagination, it's worth remembering that all great ideas sound impossible until they're tried. There's also the delicate issue of water. Mars has plenty of it, locked up as ice in the poles and underground, but releasing it is not simple. Melting the poles might flood low-lying areas for a time, creating shallow lakes and seas. Yet, without a thick atmosphere, the water would quickly evaporate and freeze again. Some scientists have proposed creating greenhouses, domed habitats where water and air can circulate freely. Little pockets of Earth seeded across a Martian landscape still waiting for its climate to catch up. These enclosed ecosystems might be the first steps toward a wider transformation, letting biology do what machines cannot. That idea, using life to shape a world, is where terraforming meets its most poetic form. On Earth, it was microbes that first transformed our atmosphere, releasing oxygen through photosynthesis and turning a toxic haze into breathable air. Perhaps one day, genetically engineered microorganisms could do the same for Mars, slowly enriching its sky with oxygen and trapping warmth in its soil. It would be slow work, taking centuries, but it would be life-changing life, evolution by design. Yet, before we dream too freely, there are ethical questions. If Mars ever hosted life, even microbial, should we alter it before we've studied what remains? Would terraforming destroy evidence of the planet's original state? Some argue that we should preserve Mars as it is, a pristine natural laboratory, untouched by human interference. Others believe that shaping the planet would be the ultimate tribute to nature's adaptability, a continuation of the same process that once turned a barren Earth into something living. There's no easy answer, only reflection. Beyond the ethics and engineering, there's the philosophical allure. Terraforming Mars is not just a technical problem, it's a story about imagination. It's humanity asking whether we could make another home, whether our creativity can outlast our limits. Even knowing how difficult it would be, scientists still model, calculate, and dream, not because they expect it to happen soon, but because it connects us to the bigger idea that worlds can change. The first person to seriously imagine a green Mars was the science fiction writer and astronomer Carl Sagan, who proposed melting the polar caps with dark dust in the 1960s. Since then, generations of thinkers have refined and expanded the concept, not out of arrogance, but curiosity. Each new idea, whether practical or poetic, reflects our deep desire to understand how planets evolve and how fragile their balances can be. In thinking about how to make Mars warmer, we've also learned how to keep Earth cool. Even if full terraforming remains centuries away, and perhaps forever beyond reach, the smaller steps toward it have practical value. Learning to grow plants in Martian soil, to extract oxygen from carbon dioxide, to generate heat and energy under a thin sky. These are technologies that can help us both on Mars and at home. The dream of transforming another planet has already inspired real progress in sustainable energy, closed-loop ecosystems, and atmospheric science. The fantasy feeds the fact. And so, when people speak of terraforming Mars, they're not necessarily talking about creating an Earth twin overnight. They're talking about the long arc of human imagination, about reaching for what seems impossible because the act of reaching changes us. Whether Mars ever turns blue and green is almost beside the point. What matters is that a cold, distant world has made us think about our own, about what it means to shape, to care, and to coexist with a planet rather than simply inhabit it. One day, if humanity endures long enough, perhaps the idea will no longer be fantasy. Perhaps, centuries from now, under a thicker sky, the first rains will fall on Martian soil, and someone will stand there and watch droplets ripple across a shallow sea. Maybe they'll remember that it all began as a dream, a fragile hope whispered in laboratories and stories, born from our endless fascination with a small red world that reminded us how precious and rare life really is. Until then, Mars remains a canvas of possibility, frozen, quiet, waiting. And maybe that's enough for now, to look at it and imagine what might be, to wonder how far we could go, and to remember that before we ever shaped another world, we learned to dream of doing so. Imagine standing on Mars, the first footprint pressed into red dust that hasn't moved for millions of years. The sky above glows softly, not blue but a pale orange-pink, tinted by fine dust drifting endlessly through the thin air. The sun looks smaller here, about 2/3 the size it does on Earth, casting a weaker light that spreads rather than shines. Shadows are soft, diffuse, as if the whole planet were bathed in the warm haze of an endless sunset. You take a step. The ground crunches faintly beneath your boots, dry, powdery, almost weightless. Your body feels lighter too. Gravity here is only 1/3 of what you're used to. Every motion feels exaggerated, slow, as though you've slipped into a dream where everything is just slightly out of sync. The suit you wear is bulky but flexible, designed to protect you from the cold and the air that can't sustain you. Each breath is measured, filtered, and recycled, the sound of your own breathing echoing softly in your helmet. You look down at the dust rising around your feet, rust-coloured grains that have lain undisturbed for eons, and you realise that, in this moment, you are part of the first page of a new human story. For decades, humanity has been preparing for this scene. The idea of stepping onto Mars has floated somewhere between ambition and mythology since the dawn of the space age. In the 1960s, when Apollo astronauts first set foot on the moon, Mars was already being discussed as the next step, a natural progression from one world to another. Engineers sketched out concepts for giant rockets, nuclear-powered ships, and inflatable habitats. But the reality of distance soon set in. Mars is not a quick trip across a cosmic street. It's a voyage of months across tens of millions of kilometres. When Earth and Mars are at their closest, a journey might take 6 or 7 months. At their farthest, it could stretch to nearly a year. That kind of distance changes everything. In the decades since, we've learned the technical and biological challenges of sending humans there. The first is time. How to keep astronauts healthy, sane, and supplied during a voyage that would last more than 18 months, including travel and surface operations. The second is radiation. Without Earth's magnetic field or thick atmosphere, astronauts would be exposed to cosmic rays and solar storms for the entire journey. Shielding a spacecraft from that constant bombardment is one of the great unsolved problems of interplanetary travel. Then there's gravity, or rather, the lack of it. Months in microgravity cause muscles to weaken and bones to thin, making even standing difficult upon arrival. Yet none of these obstacles has dampened the dream. NASA, SpaceX, the European Space Agency and others all have long-term visions for crewed missions. NASA's Artemis program, aimed at returning humans to the Moon, is designed partly as a training ground for Mars. The Moon offers a place to test technologies for life support, radiation protection, and surface construction, a halfway step toward the Red Planet. SpaceX, meanwhile, imagines fleets of reusable starships ferrying people and cargo to a self-sustaining Martian settlement. It's an audacious vision. Domed habitats glinting beneath a pink sky, greenhouses glowing faintly with the first crops grown from Martian soil. But long before such settlements, the first mission will likely be modest. A handful of astronauts landing for a few weeks or months to study, collect samples and test equipment. Even that would be extraordinary. Picture the first habitat module resting on a flat plain, surrounded by dust so fine it moves like smoke in the weak wind. Inside, astronauts work quietly, their voices calm but tinged with awe. Outside the narrow window, the landscape stretches to the horizon. Endless, rust-red plains interrupted by scattered rocks and distant hills. It looks barren, yet there's beauty in its simplicity, a serenity found only in untouched places. To step outside that habitat for the first time would be an act of courage and wonder. The surface temperature could swing from mild during the day to colder than Antarctica by night. The air pressure would be barely strong enough to support a whisper. Yet the sensation of moving under that salmon-coloured sky would be unlike anything experienced before. With 1/3 gravity, walking becomes a bounce, every step a small leap. Objects fall lazily, as though reluctant to commit to the ground. Even the horizon looks different, closer, curved, and vast. The first footprints will not sink deeply. The soil is too dry and compacted, but they will last, perhaps for millions of years, unblurred by rain or wind strong enough to erase them. On Earth, time washes away traces of our passing. On Mars, it will preserve them. Each print will be a message, not to the planet, but to the future. Living there, even briefly, will be a balance between awe and routine. Astronauts will wake to a weak dawn, their clock set to a day just 40 minutes longer than Earth's. They'll monitor power levels, clean dust from solar panels, and check oxygen systems. Every movement outside will be carefully choreographed. Every mistake could be fatal. Yet between the checklists, there will be moments of quiet. Standing by a window watching the pale sun drift lower, or gazing at the distant gleam of Phobos as it speeds across the twilight sky. These small moments will define the experience more than any grand achievement. It's easy to romanticize this future, but the reality will be harsh. The thin air provides almost no insulation, and the omnipresent dust will be a constant hazard. It clings to everything, grinding into seals, scratching visors, clogging filters. Communication with Earth will have a delay of up to 20 minutes each way, turning every conversation into a slow, patient exchange. And the isolation, millions of kilometers from home, knowing that rescue is impossible, will test even the strongest minds. Astronauts will need to carry with them not just science and technology, but resilience, humor, and the quiet capacity to find beauty in solitude. Yet for all those risks, the allure remains powerful. There is something timeless about the idea of being the first to touch a new world. Mars feels close enough to imagine, but distant enough to remain mysterious. It is not a lush living paradise. It is stark, quiet, and dangerous, yet it calls to something deep in the human spirit. The same impulse that drove explorers across oceans now turns our gaze toward this desert of another kind. The first view of Earth from Mars will be a small pale blue dot, faint but unmistakable, hanging in the dim sky. It will look fragile, like a memory. That sight alone may change how humanity sees itself. One world seen from another, the first true portrait of home from the perspective of a frontier. Future explorers will likely stand there, suit covered in red dust, and realize just how intertwined the two planets have always been, one where life began, the other where its curiosity landed. Some scientists and engineers believe that by the middle of this century humans might actually set foot on Mars. Others think it will take much longer, but time, in this case, feels less important than intent. The journey to Mars has already begun in every rover, every simulation, every student who looks up at the stars and wonders what it would feel like to walk on another world. Each generation brings the dream a little closer. When that first step finally comes, it will be both monumental and strangely quiet. There won't be an audience or a countdown, just a person descending a ladder, boots touching alien soil, and the soft crunch of dust underfoot. The words spoken may not be rehearsed or dramatic. They might simply be an exhale of disbelief, something humble and human. We made it. The first colony, whenever it arrives, will likely be small, a scattering of habitats connected by tunnels, powered by solar arrays, and supported by careful recycling of air and water. Green sprouts in hydroponic trays will be the first plants to photosynthesize under another sun. Each one will represent an act of optimism, life taking root in a place that once seemed impossible. Over time, small steps will build into permanence, a few footprints, a base, then a settlement, and one day perhaps a city. The thought of such a city is thrilling and sobering. A skyline against a peach-coloured horizon, domes glowing with artificial dawn. Children growing up never having felt rain, but knowing how it sounds through recordings from Earth. The very idea of what it means to be human will expand, not just a species of one planet, but of two. And through it all, Mars itself will remain both a home and a teacher. It will remind us of fragility, of patience, of adaptation. Its thin air and endless silence will force humanity to listen more closely, to plan more carefully, and perhaps to appreciate the blue planet left behind. One day, the first human may look up from that red plain and watch Earth rise over the horizon, a glowing blue crescent against a dusty sky. In that moment, all the centuries of dreaming, all the risks and failures, all the quiet persistence will converge into a single truth. We were always meant to reach out, to step gently into the unknown and leave, in the red dust, the unmistakable imprint of curiosity. Mars, for all its distance and silence, is not just another world. It is a mirror, a frozen red reflection of what could have been, or what might one day be. When we study it, we're not only learning about a desert 400 million kilometers away, we're also learning about ourselves. Every scar on its surface, every wisp of its thin air, every memory locked in its rocks tells a story that echoes faintly of Earth's own. Mars shows us how fragile worlds can be. Long ago, the two planets were not so different. In their youth, Earth and Mars shared many traits. Both had thick atmospheres, magnetic fields, and liquid water flowing across their surfaces. Mars may have even had lakes and shallow seas that glimmered beneath a warmer, thicker sky. Then, slowly, their paths diverged. Earth stayed vibrant and alive, wrapped in oceans and clouds. Mars began to fade. Its magnetic field faltered, its atmosphere thinned, and its rivers froze. What was once blue turned to red. The question of why that happened, why one planet thrived while the other fell silent, is one of the most important stories in planetary science. It's also a cautionary one. Mars teaches us that habitability is not permanent. A planet can be rich with water, warmth, and potential, and still lose it all if the conditions shift even slightly. The beginning of Mars's decline can be traced to its size. At only half Earth's diameter and 1/10 its mass, Mars cooled much faster. The molten dynamo in its core, which once generated a protective magnetic field, began to die out about 4 billion years ago. Without that invisible shield, the atmosphere was left exposed to the constant stream of charged particles flowing from the sun, the solar wind. Over millions of years, it stripped away the air molecule by molecule, thinning it until only a fragile wisp remained. The loss of the atmosphere brought other changes. With no pressure to hold liquid water stable, rivers and lakes evaporated or froze solid. The greenhouse gases that once warmed the planet leaked into space, and the global temperature plummeted. It was a chain reaction, one event leading inevitably to another. A thicker atmosphere might have saved the water, a molten core might have saved the atmosphere. But Mars had no second chances. It became a world of deserts and frost, its once flowing rivers fossilized into winding channels that stretch across empty plains. When scientists look at these ancient riverbeds, they see more than geology. They see a possible preview of what can happen when a planet loses balance. On Earth, our magnetic field, atmosphere and water cycle work together in delicate harmony. But that harmony depends on conditions staying within narrow bounds. A change in temperature, a shift in chemistry, a loss of protective layers. Any of these could start a slow unravelling, not unlike what Mars endured. One of the clearest parallels between the two planets lies in their climates. Mars offers a natural laboratory for studying how planetary atmospheres evolve. The same carbon dioxide that dominates Mars's thin air is also the main driver of the greenhouse effect on Earth. On Mars, there isn't enough of it to trap heat. On Earth, we have more than enough. In a strange symmetry, one planet froze because it had too little greenhouse gas, while the other now warms because it has too much. By studying Mars, scientists can model what happens when a planet crosses the line, in either direction. The data from orbiters and rovers show how subtle changes in composition can transform climate over millions of years. They reveal that carbon dioxide isn't just a problem, it's a balancing act. On Mars, it escaped into space, and the world froze. On Earth, it's accumulating, and the world warms. The lesson is not that carbon dioxide is evil, but that stability is precious and easily lost. There's another warning written across Mars's surface: erosion without renewal. On Earth, weather, vegetation, and tectonic motion constantly recycle materials. Mountains rise and wear down, oceans shift, and continents drift. Mars, with no plate tectonics and little weather, is static. Its volcanoes are extinct, its rivers gone, its surface largely unchanged for billions of years. It is a planet caught mid-breath, frozen in time. The fact that its oldest craters still sit nearly untouched reminds us that without movement and change, even a world full of potential can fall into stillness. Yet Mars isn't only a warning, it's also a teacher. The study of its atmosphere and soil has shown us how planets lose gases to space, how magnetic fields protect habitability, and how climate systems can collapse. These lessons aren't abstract. They feed directly into our understanding of Earth's future. Climate models that predict rising temperatures and thinning ozone owe much to what we've learned from our red neighbour. The more we understand why Mars lost its water, the better we understand how to keep ours. Mars also offers perspective, an emotional kind of science. To look at its frozen valleys and think, this was once alive with water, is to glimpse Earth's own vulnerability. It reminds us that our blue planet is not guaranteed its colour. The difference between a living world and a dead one can be a few billion years and a few unlucky shifts in physics. Even its dust storms carry lessons. Mars's storms can grow to cover the entire planet, fueled by small feedback loops of heat and dust. They show how interconnected everything is, how a little warmth can lift dust which traps more sunlight, which creates more heat, and so on. On Earth, we see the same feedbacks in our climate. Melting ice reflecting less sunlight, warming oceans releasing more carbon dioxide. Mars, stripped of complexity, lays those processes bare. It's a simplified model of what feedback loops can do when left unchecked. Some scientists think that Mars could have supported life long ago, not cities or forests, but microbes living in its shallow seas or beneath its soil. If that's true, then it carries another message, that life itself may depend on planetary stability. A small shift in atmosphere or temperature can extinguish entire biospheres. Life is tough, but planets set the rules, and Mars's rules change too quickly for biology to keep up. At the same time, the continued search for Martian life reminds us of how resilient life might be. If something microscopic still lingers there, in briny subsurface water or frozen permafrost, it would mean that life can endure even in the harshest environments. That discovery would not only change biology but philosophy. It would prove that the spark of life, once lit, can persist almost anywhere. And if that's true for Mars, then maybe the universe is full of such sparks, scattered across cold deserts waiting to be found. In a quieter sense, Mars teaches humility. We like to think of Earth as permanent, but the solar system shows us that worlds change, sometimes beautifully, sometimes tragically. To see Mars as it is today is to look at a once habitable world that fell into silence, a reminder that nature doesn't guarantee second chances. It encourages us to think long term, to treat our atmosphere not as a given, but as a privilege. It also shows us that the line between thriving and barren isn't as wide as we once thought. The same elements that make Earth fertile exist on Mars: water, carbon, sunlight, but arranged just slightly differently. A few percent change in mass, a slightly stronger magnetic field, a little more volcanic activity, and Mars might have been another blue world. That fine margin should fill us not with fear, but with awe. It means that every day on Earth, every breath of air and drop of rain is a small miracle of balance. As exploration continues, Mars's lessons will grow clearer. The instruments that study its atmosphere and geology are not just looking outward, they're looking back toward us. They tell a story of cause and effect, of planetary fragility and resilience. They remind us that climate is not a static condition, but a living system that can rise or fall. Standing on Earth, with our oceans, clouds and forests, it's tempting to think of Mars as distant and alien. But in truth, it's a sibling, older, quieter, and marked by experience. It shows us a version of ourselves stripped bare. the bones of a world that once dreamed of being alive. Perhaps that's why Mars has always fascinated us, because it reflects both our potential and our peril. It shows what happens when a planet loses its shield, its warmth, and its voice. It's a mirror held up to Earth across space and time, asking a single haunting question. Will we listen to what it's trying to tell us? For centuries, Mars has been more than a planet. It has been a mirror for human longing, a place where science, imagination, and poetry all converge. Of all the worlds in the sky, none has captivated us quite like this small red desert. It isn't the largest, the brightest, or even the most mysterious, but it sits at the perfect distance to make us wonder. Mars feels reachable, almost familiar, and yet just far enough to remain a dream. That tension between closeness and impossibility is what keeps humanity coming back to it again and again. When people first turned telescopes toward the heavens, Mars was already known as the wandering red star. To the naked eye, it glowed like a coal, steady, ominous, but oddly warm. Its colour alone set it apart, linking it to fire, blood, and vitality. It was the only planet that looked alive. Even before we understood what it was, we sensed that it carried stories. It moved against the stillness of the constellations, sometimes bright, sometimes dim, sometimes even appearing to backtrack in its path. It was restless, like us. As astronomy grew, so did the myth. By the 19th century, Mars had become a canvas for human imagination. When Giovanni Schiaparelli mapped its surface and described canali, the mistranslation to canals ignited a century of speculation. People imagined engineers building irrigation networks to save a dying world, and astronomers like Percival Lowell dedicated their lives to proving it. That idea of a world trying to survive, of beings reaching for hope in the face of desolation, resonated deeply. It was not just a scientific theory, it was a reflection of human endurance. Then came the storytellers. H.G. Wells unleashed the War of the Worlds in 1898, turning Mars into the origin of a terrifying invasion. His Martians were not villains so much as desperate refugees fleeing a world gone cold. The novel struck a chord, not just as science fiction, but as social commentary. It forced readers to imagine Earth through alien eyes, to see ourselves as the vulnerable ones. From there, the floodgates opened. Edgar Rice Burroughs painted a romantic Mars in his Barsoom series, where warriors leapt across crimson plains and princesses ruled ancient cities. Ray Bradbury's The Martian Chronicles later gave the red planet a melancholy soul, a place haunted by beauty and memory, by what might have been. In every era, Mars has been what we needed it to be. When the world was full of optimism, it became a frontier. When we feared war and collapse, it became a mirror of our anxieties.